Yeah.
Continue talking. Okay, now it's
Yes.
recording.
Okay. Global workspace-like representations. Yeah, I read most of the words at the beginning, and I looked into some of the math so far. It's pretty interesting, and it caused so much drama on Twitter. My feed wasn't for a day. My feed was only about this because I'm so skeptical about. I don't know. Well, I mean, workspace theory is weird on its own in consciousness science. So, but yeah, I think functionally it's pretty interesting. As in, from interpretability perspective, I think it's pretty interesting that they find these reoccurring representations that they can edit that indirectly edit the reasoning steps, which are not in the input or in the output when the model is generating something. They can be transferred across contexts, so they can generalize. And they are pretty small subset. And they can be, like, if you ask the model, it will report it differently. So, like, there's verbal report and stuff like this. Yeah.
Well,
and how they do it using JSpace is pretty cool, which is Jacobian.
I do have some thoughts of that, but I will get there. Like on the verbal reporting, in some sense, that part is something you should expect. In that, with the, as I understand how the Jacobian thing works, you are kind of looking for activations that will make the model say something, you know?
Yeah. Perturbations, my understanding now, the perturbations in the activations, it quantifies that the perturbations in the activations will change the final output. So, the causal importance of the particular activations on the final output.
Yeah.
Is my understanding. And it's an improvement of Logitlens, I guess, is one perspective to see this. I think they even explicitly say that in there.
Yeah.
Which makes sense.
Unless
Because,
you can see it's an improvement that is another way of relating. It's kind of vague like improvement. That is another thing that has the activations as input, that tokens as output, and is vaguely trying to find out what the token is, like the model is thinking about or something like that. I guess both things are actually just looking at different things, probably in practice. But yeah.
Yeah, I think if you set the Jacobian to identity matrix in the whole pipeline, you basically recover a Logitlens. Or something like that. When you're doing the GLN.
Well, not exactly. I think that the thing you said wouldn't be the same. Or like, what do you mean the identity matrix? Like, what are you saying?
I think in the JLens, I might be wrong there though. That in the JLens you multiply the Jacobian matrix with the layer you're trying to interpret.
Right.
And then running it through an embedding layer.
Yeah.
And in Logitlens, you skip the multiplying. So if you multiply it by the unit matrix, it's like you did nothing. And then you run it through the unembedding layer.
Oh,
I think I might be wrong there. I don't know.
So you mean if you remove the Jacobian part?
Yeah, basically that's equivalent.
Okay, yeah. I guess it's some weird way to say it because that's just Yeah, if you just multiply by the
Yeah, if you multiply by identity matrix, it's like you did nothing.
do you actually multiply by the embedding? I guess like we can like
Yeah, I'm
doesn't
not
the
sure exactly.
Jacobian already give you some score for the each token that embedding though?
Oh, they directly say in the paper what I said. I just find the line. The logit lens applies the unembedding matrix directly to the intermediate residual stream, which corresponds to setting the Jacobian to identity matrix in our formulation. Okay. That's
Okay.
directly in the paper as well.
Okay, not sure I thought I was maybe hearing how they calculate the Jacobian stuff.
Yeah. It's in the
Uh,
2.4 comparison to other reality techniques. If you wanna see the line. Okay.
By the way, as usual, like, everyone else, feel free to unmute and talk or write on the chat. Also, I wasn't paying attention to the chat. Maybe someone wrote something. No, not really.
Nothing to check.
Yeah.
I
So
think it's pretty good to first go through the examples in the introduction, and
okay,
then
let's
into the
let's
math.
go back to the introduction then.
Yeah, specifically the visualized examples probably. I don't know. I read the whole introduction. I think it's pretty cool.
The minding assumption is
Yeah,
the thing that you were
I
saying, like the
I used to meditate too much on mind being an ocean, so this is kind of
uh-huh,
it's funny.
like it's reward hacking your brain.
Yeah, basically. It's too
Adversarial
relatable, I think,
as an
analogy.
adversarial example for your brain.
Yeah, jailbreak.
Your reward model.
Oh well.
Anyway, hi Nika. Yeah, that's about
There's
Thanks.
a description for how the global workspace works, and I feel that's pretty important because when I was reading this article, I noticed that there was a bunch of descriptions about what the properties of the global workspace are, and like
Yeah.
it's pretty important because there's a couple of properties of the JLens that uh, that you just simply do not observe with other interpretability techniques like activation oracles, for example. So like when you use an AO, you can't actually like elicit the intermediate reasoning steps when you tell a model to think about something while answering something else, right? So you can't do that with an AO. The AO just hallucinates, but the JSpace actually recovers it. So you should actually like
Mm.
read that section.
Mm. Yeah, I
Yeah,
mean we'll get
there's
to
a
that one. Yes,
section.
I guess we should
It's
look at the introduction first, but yeah, we can go to that
yeah,
one
Right.
after.
it's in the introduction. That they say the properties in the introduction.
Okay. So
Maybe more detail later. I think at the end of the paper there's a comparison section
yeah.
more gradually.
Yeah. So they are just talking about. I think this is you can separate this from the global workspace theory stuff. Of I think they make some case for like the J lens relating to something vaguely like functional access consciousness in the model, in the sense that they have some things that the models can like are in some sense aware about, that they are thinking, in that if you ask them what are you thinking, they will say the thing and it will correspond with the J lens, and this seems like
Yeah,
to be causally relevant. While there are other things that don't correspond to the J-lens and are like in some sense unconscious, in that the model, if you ask it, it cannot say them. Although maybe I haven't read the whole thing, but it feels to me like it doesn't need to be that the the kind of space that you look through the J lens is like very separate from the rest of the model, or like more special or something, in that with the Jacobian thing, as I understand it, you are finding the activations that will cause the model to say it in some context, right? So this is not just the ones that will, when asked what are you thinking, make it say the thing, but if those activations exist, they will show up on the J lens, right? Although I guess it's more interesting if like how often can models verbalize what is on the J lens result. I like if it's almost always, that's interesting. But they're still like I kind of trying to say that I feel like the methodology here kind of gives you that for free, that the thing that the Jalen shows will be verbalizable, because it's found by looking by some things that will cause the model to verbalize it later in some situation. Let's say the token. But yeah.
Yeah, verbalization
but
is one of the.
is it really
keys.
correct to say that that's true? Because like they're trying to measure whether the residual stream has been influenced, but not that the logits are being recovered in the future time steps. Like, does that make sense? Maybe I misinterpreted it, how it
No, not
works.
sure I understand what you're trying to say. Can you try to explain it more or something? I don't know.
So in the formula for the J-lens,
Yeah.
they're trying to maximize they're trying to take the Jacobian with respect to the final layer activations, or like the activations of a different layer. Is that correct?
Yes. That they
And they're doing that over future tokens. So here you can scroll to the formula, I guess.
Yeah. What is the
Okay.
formula?
I'm sorry to be butting in. I'm not sure if the flow of the reading group has covered the formula yet. Have we gotten to that part yet? I
No,
should ask that
we
first.
haven't. I mean, we just started. But no, I
Okay,
think
we can just get to it later then.
I mean, I think it's a good thing to do. But okay, let's. Yeah, I mean,
We
we
should just
just
get to it later then.
okay. Let's go in order. So
Yeah.
I was just saying broad things about the paper, but yeah, maybe we should just read the thing there. But I think that's important to discuss, because it's like one of the main things, like exactly what is the Jacobian lessons doing exactly,
Yes.
and then we can see what we can figure out on the thing. Okay, so they talk about so there's the motivation. They talk about access consciousness and whatever. They talk about how they are not talking about phenomenal consciousness, although Twitter will talk about this forever. But yeah, functional
Yeah, like
role.
like I think one of the things there is that, yeah, I think you posted it actually. Someone commented on how like if you believe in global workspace theory in the brain at least, then some people say that there's no like that the excess consciousness implicitly implies
Yeah,
phenomenal
that's also
consciousness. So
that's a position.
that's kind of an contested thing, I guess,
I do
in the
want
consciousness
to.
wars.
I do want
I
to
mean, why
say that
does the global workspace have to be conscious?
Say again?
Why does the global workspace have to be conscious? Like, what's
I
the
don't know.
argument
It's
there?
probably assumption. I
I
don't
mean,
know the
the
argument for
global
that.
workspace theory is trying to be a theory of access consciousness, and there are some people who's like there is philosophical points where if something has that, it has phenomenological consciousness. But yeah. Usagi said, just enjoy the math, guys. I think maybe that's how maybe we should look at the math and don't spend all day arguing about the philosophy stuff. But yeah, I don't know. I do want to say about that briefly that I feel like you can separate global workspace theory from the access consciousness stuff, in that something could not fit all the. For starters, people don't agree that the global workspace theory is true for humans. People just agree that humans have access consciousness. I think some of the things on this paper looks like something like LLMs have also functional, functional access consciousness or whatever. Regardless of whether it fits exactly the workspace theory or not.
My hot take is that we shouldn't call access consciousness. It should be just access functional something. Whatever.
Yeah, I mean, I don't know. I mean, it has
It doesn't
access
feel-
already. Like, it's a second word of consciousness you can separate from the other, which is
Yeah, it's
phenomenal
just access. So it's access algorithm. I'll say that.
Whatever.
Whatever. Let's
In
go
any
to the math. The math is cool.
Let's. I
As
think
much as the
Twitter
philosophy.
already argued enough about that. I think I said my thing.
Yeah.
I'll continue. If people want to argue about that later, we can argue about later. But let's try to. I think I'm going to just go to the math part. Yeah, so like go to the actual. What the main thing of the paper is, which what this J-Lens stuff.
Like, I think it's still nice to read in the introduction the section on the different functional things.
Yeah.
The workspace like things, because then they try to like empirically find them. So it's
Verbal report has yeah. Okay, let's read it. So verbal report have empirical concept of access. Is the Jacobian technique new? Asks Descartes. Yes. As far as I know, I mean, maybe there is
yeah.
some obscure paper they accidentally Schmidt-Hubered, but I think it's
So
new.
I saw some tweets Schmidt-Hubering it, at least applying Jacobian
I mean, I
in the
think
context of,
Jacobian
but not this
is
way.
yeah.
How Anthropic did it. So like they apply Jacobian apparently on hidden states, but in a different way than how the
Yeah, I don't know. I feel
Anthropic
like
actually
Jacobian is
applied it.
pretty simple. Like it is a pretty simple enough thing that people will have applied a bunch of things, and unless
Yeah.
it's on this on the embedding, I wouldn't count it the same technique. Maybe
It's also yeah. So it also uses linear approximation. I wonder if I can find some Schmidt-Huber tweet. Schmidt-Hubering.
Okay,
They're
so
deep,
it's
deep,
suggested
deep in
under
my likes.
control, can be interpreted on it, having in mind as anti-maze, meeting with the better relation, and yeah, they're talking about the properties of access consciousness. Permits flexible generalization, the same content to whether patient the current as the master. Yeah, I think they may show this, like that models maybe seem like it have, but we'll see. But and I feel that this seems like a big thing on the consciousness that things seems to be better to just think about like access consciousness stuff instead of the global workspace theory, because the global workspace theory is just like a even more specific thing, and it's not necessarily even right about how the attention works in the brain. So yeah.
Yeah.
But yeah, many specialized processors operating in parallel in isolation, and like who knows if it is very vague, and I don't know if it applies to no. Apparently, the global workspace theory people would think they do. I think it does, but whatever. This is probably too vague to.
There are some tests apparently, and it's partially true, partially false.
Report. Whatever the Holper's has to be is competitive and potential remuneration. Context workers, yeah, whatever. It's not universal thetis. Find useful compared to ground to investigate language models. Okay, I don't know if that's useful, but we'll see. It's just making them overfit their thing to the paper, to the global workspace. Okay, a global workspace in language models. A common representation format allows intermediate results to be written once and read by many neural processes. I feel, yeah, maybe they'll explain this more, but represent this is high dimensional vectors with a comparison of primitive vector representation with splitting confidence. Yeah. Some of the representations belong to it, but not all. The question becomes, I mean, why not? Could be that all belong to it. So set that place potential to workspace. Following properties. Yeah. I don't know, I feel like how to say it? This is maybe overfitting too much. Like thinking about it, it talks about like a common you know, like there is some common way of representing things. It feels like the actual neural networks, like there is less a sliding scale of how much different circuits reuse representations and all that, and maybe it turns out there is something like some set of things that are like very broadly used, but doesn't feel like there has to be like some necessarily some sharp distinction. I mean, if there was, I don't know if they would find it with the J lens. Instead, you know, the things that activate the J lens more might.
A sharp distinction between what exactly?
So you could imagine
between these properties.
You have some properties that like on the property of like I mean on the part where they talk about what was it?
Like that it's more of a gray spectrum than like this is in
Yes.
workspace, this is
Like
not in workspace.
specifically
Yeah, I
the
think
thing
that's true.
with parameters is whether different parts of the model use the same reuse the representation. Like that there is you have the model, some part of the model writes some representation of a thing, and other parts of your model that use that concept, whatever, are reading the same representation. I mean, I guess you kind of would expect Gradient Descent will make when it can, will try to make most things like that. And I don't know. It seems like a weird ontology to try to map to how the language models work.
Like I guess it makes sense as a one lens out of many. That's my perspective now.
Okay. Well, I guess I think there are other properties that maybe are more interesting. Okay, so verbal report. As well as thinking names concepts as presented in Workspace. Swapping a table perspective for another chunk is set to max. That's interesting, yeah. But I guess it's kind of maybe structurally promoted by the way the J-Laser works, but we'll see the math after. Directed modulation. When starting to hold a concept in mind or perform meta equations, the model is capable of activation and computing with two workspace vectors, independent of its outputs. People are joining my living, but never mind. Asian information that is not typically presented in Workspace can be pulled when the task requires it. Internal reasoning. Workspace procedures can be used to represent value of intermediate computations when the model changes inference steps or composes plans. And it will create the conclusion. Okay, that's... Yeah... Resume generalization. Same representation serves as a valid argument to many different demonstrated computations. It's correct. I mean, I feel like this is true for a lot of the. This will true for a lot of the vectors in a lot of the features. If you go to Sparse encoders and pick random features, you'll probably find this, right? It's not like, I don't know, you find that the Golden Gate Bridge feature only activates on the Golden Gate Bridge, like on some very specific sample. And there is other kind of things.
I'm not sure what you mean exactly.
Okay. I guess the thing is coming to mind when I do this. It's how much of this is just what you would expect from, let's say you use the JLens and it gets you some subset of features that cause the model to verbalize them if asked?
In this case, it's I wouldn't say subset of features because you get tokens through the edited logit lens, basically.
Yeah, but I mean,
but
like
they talk about how to make it features later, I think.
Yeah, no, but I'm thinking like if you do the JLens and you pick the token, right? You are going to point to a set of features that will cause that token, and are you just picking as like imagine if you just pick some feature on the model that has that, wouldn't it already wouldn't features on the middle layers wouldn't you already expect to have a lot of these properties? You know what I mean?
You mean properties as in having causal influence over
I mean,
class layers?
you should expect them to, I guess.
The verbal report and stuff, you mean?
Yeah, verbal report, it seems like structurally from the JLens. Directed modulation is maybe the interesting one. Internal reasoning, I mean, yeah, there are some subsets of features that will be used for internal reasoning, and maybe a lot of them are into the layers that where they're finding the thing, you know?
Yeah, that some of the cross-layer transcoder stuff also shows the internal
flexible
reasoning
generalization, I think it's a property of a lot of activations, like a lot of features that you find even with the methods like Pearce encoders. They'll usually have flexible generalization because Gain Descent doesn't want to, prefers to reuse stuff.
Yeah, they have a section on comparing with different methods. I wonder what they. I think.
Yeah.
The first one is the
selectivity one is interesting, but it seems like there is some subset of activations that activates the JLens, and it's related to some specific thing. But yeah, maybe there is something about how the JLens is constructed that tells that, or maybe that tells us something about how the model works, like that. The kind of things that activate the JLens also only seem to matter more for some specific kinds of things.
Features in the JSpace. They talk about features in the JSpace and they talk about essays in that section in appendix.
Mhm.
So if you want connection with essays, there's a section for that. A18.
I mean, I'm not really correct to say. I was thinking of features like more at the general concept of there is some parts of the activation space that do stuff.
Yeah,
But yeah.
superposition. For each essay feature, we can ask the extent to which it lies in the J space. They try to find this relationship.
Yeah.
We know that essay features an imperfect decomposition of the representational space. Okay, this could be combined with the unsupervised manifold stuff. Yeah.
Okay, also, yeah, looking at the figure, so, yeah, you ask Claude, what are you thinking about? And then you swap the thing and it makes it output an elephant. And
Yeah.
it can do compute. This was it. Okay, this one it's pretty non-trivial on the directed modulation that the model can do that kind of thing in multiple steps while writing something else.
Someone in the chat is like
I mean, yeah.
Yeah, it has been going for 40 minutes, but at the beginning we got a bit stuck talking about the excess consciousness claims.
Yeah, I mean, I also we started a bit later than that, but you know, we were joined the call first and then set up things and then wait for people and all that. But yeah, we got started with the access consciousness stuff. And there's a big paper. We are going to be here for a long time.
And the Carl is asking if JLens improves LogitLens by utilizing the Jacobian to pick out the most important parts of the activation stream according to the large database. I'm not sure if that's the exactly correct wording. I think I also see it as like coordination.
No, yeah, I don't think
shifting of coordinates.
It doesn't work like that. I think the JLens is looking at a different thing than the LogitLens. Because it's looking at using the Jacobian, but it's like it's most important for specifically causing the model to output specific tokens, I think.
It transports it into that space.
Internal reasoning. What color is the planet force from the sun? And yeah, you can swap the which planet the model is thinking about with the aliens, and it makes it output a different color. But I mean, we don't know from previous anthropic papers, and it's not that if there are some features like the circuits for this kind of question works that way, where the kind of way where you this makes it output the fourth planet on the sun thing, and there is some which color is this planet circuit, and they just compose. That's like the kind of thing you see on the activation graphs for previous anthropic papers. So it's already makes sense that this will work that way. I think but it's interesting anyway. Oh, so yeah, this stuff is just they are doing kind of steering, but with the lens basically. Capital of France, China. Change the thing. Selectivity. Parse input record.
Yeah, okay.
I think for the answer to your question, I think we'll go to the on this section now. It's going to be about how the Jacobian lens unfortunately, it's better we just actually look at it, how exactly it works. But yeah, okay. For each token in the model's vocabulary, the Jacobian lens identifies a vector representation that equals the potential for the model to verbalize that token in the future. Concretely, it computes for each layer the average linearized effect of activation on the model's likelihood of producing a particular token, now or in the future, average over a large corpus of texts.
Yeah, I think linearize because you just take one derivative.
I mean, I think this is going to mix a bunch of stuff. This is going to mix things that will cause the model to say it later for a lot of different reasons. It will also cause have things that cause the model to say it right now. Although I guess if you average for a lot of steps, it's going to be more say later because most words are not a token. So if you use the average part of the whole dataset helps. Yeah, so the average step is key, as it distinguishes representations that are verbalizable. Sorry. Points to be spoken about. Should the occasion arise? From those that mainly, this is why I was talking about the fact that the representations are verbalizable is maybe less interesting because like the J lens is in some sense trying to find the verbalizable representations. The interesting thing is the verbalizable representations have other interesting properties. But yeah, okay. So going back to the Jetcar thing, so I think the thing is like the thing I will say to change your previous comment is that it's the most important parts for according to the literature, at least the more important parts for making the model talk about some token or like say some specific token in some database. Or like some there's some training data basically. I don't know if
You can
that
ability to change it for different reasoning step. And it's also which doesn't appear in the input or output. Well, it can, but it doesn't have to. The ones that are classified as workspace like are the ones that should not appear in the output and output.
Okay, so they then find that if you look at this verbalizable activation, like at the kind of activations that will have make the Jacobian go up for some specific token, then that they seem to have some other interesting properties that they relate to attention and the workspace theory stuff. Yeah, I mean, kind of. So the thing that Theodore said, kind of. So the way the logic lens works is you take an embedding for on that layer, like some layer, right? But that's kind of like what each layer will predict. But the thing is, the layers are not set up to predict stuff. So it's doing a weird thing, really, where it's sometimes on earlier layers when you do that embedding, it does seem to have things about the model is trying to think about for future tokens, because the model doesn't have to only represent the next token on the current step if it's not at the last point. So the logic lens kind of does a bunch of weird things, and it's not always like super interpretable, but it did have some amount of finding things the model is thinking about too. But not that good because it was mixed up with what the next token is and all that.
Technically, this is a generalization of logit lens because the matrix can be anything. Oh no, my generalization brain is speaking. Shut up, you are not making any predictions. Okay.
I
mean, but I think that's an interesting question. Like, you can multiply by anything. What if you multiply by second order derivatives?
I feel like
Does
there's a
that
thing
give
where
you
they're
some
talking about.
information?
Okay, so they're talking about the space, and when the space they're just talking about the things you find on the lens. I feel like they have some evidence here that they have some evidence here that that there is some kind of workspace thing on the model, but I feel like they should. I was thinking before reading the thing that maybe they meant that by J space, but it seems like not. They are not talking about the workspace, and they're talking about using J space as just talking about what you find with the J lens. But it feels like you should probably think of it as separate. Like if the model does really have some workspaces kind of thing, you should be able to find it. Like for example, even here, the workspace thing is only matches the J lens in some set of layers. I feel like they should have just. I mean, we can just call it the model's workspace or something. But I feel like they should have made a nice sounding name for it. I kind of thought before reading paper that they just called that the J space, but that would be having kind of a bad name. I guess the J space is just the space of things you find with the J lens. But yeah. Within the ledgers, it does operate this limited in capacity, which most of our represented features lying inside it. What does this mean? So this means, right, that most of the model's features don't cause the model to be more likely to output some specific token, right? Yeah, let's compare it with the model weights. Or maybe it's because it's a linear thing and most have some non-linear relationship with the output. Because I mean, most tokens I will expect have some effect on the output. But I guess it has to be in a broad data set that they cause that output, I guess, on average. Sorry, were you saying something, Gurnee?
Yeah, I'm still thinking if you multiply the Jacobian by the hidden state in the J lens, would how exactly you change the hidden state? Trying to figure it out. Like, as in, how to think about that. Since you multiply it by derivatives, what exactly does that give you? I'm not. Okay, let's see. Like, I would think, like, one thing it does is it transports coordinates from the hidden state to the final residual stream on embedding before the unembedding. So that makes it more aligned. But like using derivatives, using this linear first order closure.
By the way, I think there's a thing that. Here's the thing of finders suggest that the J space achieves many of the functional properties of the global workspace in the brain, while sharing only some of the architectural properties. Yeah, but I mean,
Functionalism, maximalism.
if you imagine like in the world where global workspace theory is wrong, like this is just evidence against global workspace theory.
Yeah.
Right?
Yeah.
Like you're saying the people who the other philosophy people who had other things attention also agree that there is functional, access consciousness with those properties. They just don't agree with the the architecture, and it's not like we know that the brain has that architecture anyway. So the combination improver tool, which we believe only approximately completely captures the modern disk workspace structure. For instance, it only identifies vectors associated with concepts that correspond to single tokens in model's vocabulary. Concepts correspond to multiple tokens. Comments and proposals processed in them. I have takes on more takes on the consciousness stuff, but I kind of want to not get lost into that because we're going to be an hour
Where's the
here
math?
and we have barely gotten to the math. Beyond characterizing the JSP's properties with storage contents. Nice. Okay. Also, people feel free to say something right in chat. Like you can also like earlier, like I don't remember the name, but the other guy said we were saying something, and I said we should go through it bit by bit, but feel free to interrupt. Like it's we don't need to have gotten to some point to talk a bit about that. I feel like otherwise I'm going to be trying to go through it, but like this is very long. We're probably not going to read the whole thing at that rate, so maybe it's better if we focus on the things that people are interested on. But yeah, if you don't say anything, I'll just keep reading in order and talking out whatever comes to mind while I do that. Why can't we find the J space? So space contents. The
Yeah.
J
I
is
think I went through most math so far except for the J space. Let's see the J
okay.
space.
The consensus is interesting in Jacobi less and less interesting in global workspace. I think that's fair. I'll try to go more into the J stuff and not get bogged down with the.
Yeah, I love both, but maybe let's fast to math.
Yeah.
and like I would also do infinite
Yeah, I guess this is
recursion
also the Mech Interp
on
Discord,
the
not
GBT.
the philosophy Discord or something. Why can't we find
I think understanding the math will also help the philosophy stuff,
Yeah.
basically.
The J-Lens reveal even on the philosophy stuff, I think the global warfare theory is not the most interesting part anyway.
In the
But
end,
yeah.
you can just subscribe to the net, and consciousness is illusion. So let's just skip to math. Okay.
Yeah, space properties for the contest. The lens where the surface is. No, the car left. Maybe they lost internet or something. But anyway, I'll keep going.
Or maybe they will first read the math themselves and then come back. I think he did that. I don't know. Maybe not.
Maybe we'll
I think he came back a few times before. Okay. Let's continue.
Yeah, internals through across layers. So colors, mass. Yeah. So
Great.
you put in this, you see different reasoning steps. There is this just a new cool way of looking at models that complements other things like the sparkling encoders and whatever.
Yeah, this is a good example. As I went through
I
this.
think we need to look a bit more into it because an important part of this kind of technique or whatever is thinking very. Try to not have a vague idea in your head. Think thinking a lot about what exactly is the tool saying, like mechanistically, what does it make it activate and all that. Protein, fluor.
Yeah, I think
Also,
Vitekar was here right, that the legit lens assumes that the early layer activations are aligned with the final unembedding, but they are not. Yeah, I think
yeah, I
that's
think
true.
that's true. I think some things are. So there are some middle layer stuff that are activated aligned with the final embeddings, but yeah, a lot of things don't. So you get a lot of gibberish. I think there are some reasons why you should expect it to match sometimes anyway. Because like especially on the more direct activations, if there is some activation that you want the kind of sense wants that activation to make the model more likely to always output that token either way, it makes sense for it to have some alignment with the embedding. Even if it's
I
also used
think
for other
Jalen's is
stuff.
partially doing that, basically, getting more aligned with the basically with the last hidden state, so that the
I
unembedding
mean,
makes more sense.
since it has a gradient step, so it can do indirect things. It doesn't have to be aligned at all with an embedding, right?
I'm not exactly sure. I'm trying to understand
Or I
exactly
guess
what
it's
now.
since linear. Okay. I guess it's linear, so it's still it cannot have some non-linear effect on the. Like it's a linear approximation of the of the of the effect on an embedding.
So
So it cannot.
each parameter, each hidden state.
Also, I feel like people are leaving. I wonder if, yeah, they're getting bored or something.
I wanna see an example there. If you go to hidden state, you get this matrix. I will go through an example that I think that will help me. This is the
Yeah. So
you have the hidden state H1 that's multiplied by
Neil
partial
had a
derivative
point
of.
in his comment of this, like the same point he had for the natural language and decoders, that this is a nice new tool to generate hypotheses about how LLMs work.
Yeah, definitely.
But I like the normal
I think that's true. That's
it
like
doesn't.
start of
It's not
encoder.
a tool for confirming anything. It's not going to be reliable for anything because it's.
I mean, what does confirming mean? Like, there is some causal influence. For me, confirming is ability to predict, ability to control. Like, I don't know.
I
That's my philosophy of
think
science there.
there
So
are things you can have tools where you apply them and then you become much more confident that some theory is true. While this is more. You have
like, what
some.
does it mean to be true? I think we're going into philosophy of science there, though. I don't know.
Okay, let's
My, my,
ignore
my,
that.
my like, for me, that's predictive and explanatory. So it doesn't matter what's exactly, yeah. And this
Yeah.
is predictive and explanatory to some degree, not fully.
I have to.
It's still
I'm not
terrible
going
though.
to get that.
Let's learn
Immediately.
causal models over LM activations, and I will be more happier. Maybe not. I don't know.
Several models sometimes encode the coordination of being automation. Catch personalized properties that waters can perceive. Okay, yeah, you can.
By the way, if you Nika, if you want, if you have some comments so far, you can also comment. I'm not sure.
Yeah.
I'm trying to catch up on how Jalen's works, and I'll join.
Okay. Sure. Or do you want me to try to explain how Jalen's works? Or do you know the math but trying to interpret it semantically?
No, I'm a bit behind. I'm going through the math. I'll catch up with you guys.
Okay. Do you know the math of logit lens, or do you wanna do it yourself?
Yeah. I don't. Yeah, the logic lens is basically apply an embedding in a previous earlier. That's all.
Yeah.
This
So
is just
this
apply
is
the Jacobian.
Yeah, so here you basically take the logit lens and then you multiply it by a Jacobian, which is this matrix of partial derivatives with the of last layer with respect to the layer that you're trying to interpret, and then they also average it over over like 1,000 prompts, I think, pre-training like prompts.
I see.
I can
So how each so in the residual stream of this layer, how nudging each element of that would affect the residual stream of last layer, and that's the Jacobian they take.
Yeah, like it's how it will cause it to, like, for all of they get in the end as a token, a dictionary size output, and it's for each token how much some change in the activations will make it output that token more.
Yeah, all the math is only in this section for the JLANs. I posted in the chat.
I
so,
can briefly go
yeah.
there. It's probably better because.
Alright, if you don't wanna skip, continue. Up to you.
No,
I'm just
I
going
think
through
it's
this one
important to look at the math a bit, and the other stuff is
Okay.
just kind of more fluff, I think. And we can go back to it, but yeah, let's briefly look at the math. Okay, so the basic idea to get the distribution fires order casual effect on the model's output. Wherever division potential contents. So we have to consider the stream H and layer L, and some token position T. As much perturbation to HL will, so the residual stream will propagate through the remaining layers and shift the fire layer residual stream H final at every position, which is the T. The next positions, like T delta, like with the tick. The first order, this decision is linear and describe the Jacobian matrix. It's not actually linear because there is ReLUs, but yeah,
This is first order approximation, yeah. Linearization. Well, that's a good point. There's ReLUs. It's a good. Well, it is not an approximation. It's a direct measure of how that layer changes. It's a linearization.
Yeah, like it's going to be wrong if there is like some effect like it's caught on the edge of a ReLU, I think.
Is it though? I think if you break propagate, so when you're doing all the chain rule, I wanna write out all the chain rule steps. Oh my god, I will maybe make Ellen do that. Like when you are trying to calculate the Jacob the partial derivatives of the final layer with respect to the layer of interest.
Yeah, we can have that number exactly. Why are we approximating Jacobian? We can have literally exact formula.
No, they're calculating the Jacobian.
Yeah.
I'm just saying that
They're doing exact, yeah.
I think they put the gradient and the Jacobian are linear approximations to the causal effect of different, like when you're taking the derivative, it is like
I think there's an assumption that the late layer change, nudge, a change, is equivalent to the small change in the layer that they're trying to interpret. And you multiply by the Jacobian to transport. You multiply it by the to transport the wait.
Like for example, on the if you do like there was the causal intervention stuff, the activation patching stuff. You can calculate the actual effect of patching different things by taking the all possible combinations of things, but that's not very efficient. You can extend to the gradient, but the gradient is an approximation of like the full. If you change this, like a linear approximation to the if you change this, how much this will change the output.
Local approximation around the reference point. Yeah, it's definitely like the change in the final layer is approximately the Jacobian times the change in the layer that you're interpreting.
At the same time, the model is trained using
That's the
gradient
assumption.
descent, which also uses the gradient as a linear approximation.
Yeah.
Causal thing. So you should expect it to have some structure that's based on that and not
So-
on.
Does linear approximation in this case mean that no matter what context you're in, regardless of whether it's a role play dialogue or some physics question or some coding question, like literally no matter what it is, same change at the same place in the residual stream of this layer will cause a similar kind of change in the final layer? Because that sounds obviously false intuitively.
No, it doesn't mean that. It's
already understand.
like so. They try to do that by doing it an average over a lot of data set, or like a lot of questions in a bit over a data set.
Yeah. They also do that.
The final formula has to be basically independent
Okay,
of
so
where
the formula, like the Jacobian, gives you the activation, like but like it's taking the wait no. So you have activation on the middle layers, and you are doing the Jacobian. Wait, how is the?
So it's a matrix.
Okay, but then you have the residual stream at some position. So you have the residual stream, and you are taking changes over that residual stream.
Yeah, but also the aspect is that like in the Jacobian it's m times m matrix. So like model times model. So like you take you have partial derivatives of the first component, the final layer, with the first with respect to the first component in the hidden layer that you're interpreting. And next to it you also have the partial derivatives of the first the second component of the final layer with respect to the first component of the hidden layer, and this way you iterate over all the possible combinations of j and k. So in the end, when you're the Jacobian includes also how like
but still, doesn't the Jacobian have to assume that basically change is the same regardless of where in the activation space you are, basically? And that sounds wrong. Like, you get what I mean? Like +1 to element 3, let's say, would mean the same thing regardless of if it's in a role play dialogue or in a physics problem.
Yeah, they average it across prompts, so
but I mean,
also gives you the
if
flexible
the
generalization.
assumption itself is wrong, then maybe averaging across prompts
Oh,
could not.
but okay, but it's so it's they taking the Jacobian from some activation, like from some residual stream that has some content. Like you imagine one of the things you said. I don't know. If you are talking about if you are in a cooking recipe, you have some residual stream that has stuff about being a cooking recipe or whatever, and then you said with this in this specific context with these activations, if you change only this one, what happens, right? So you will get different questions, I think.
I feel like if we look at the math of the J space, which is another thing, another construct in the paper that will clear some of these confusions. That is my feeling now. I think I'm gonna do that. Yeah, it is computed by backpropagating, obviously. I wouldn't be surprised. Yeah, I'm just gonna go through the paper and just focus on the math symbols and just get them first. Okay.
Also so here's the thing where they're saying that they take for the Jacobian of some layer. Applying the lens to the activation of HL is equivalent to replacing all subsequent layers with the appropriate lens matrix, followed with the number and embedding operations.
Yeah, they just say that you don't do the rest of the model forward pass. You just pass it through the unmembered matrix instantly while adding the Jacobian matrix. So it's like
okay,
legit lens
so
with the Jacobian
the
matrix.
Jacobian matrix will give you, so basically this is equivalent to, so with the Jacobian matrix it gives you for the gradient approximation of the effect on one layer into the next, and then one layer into the next, and so on, right?
Oh wait,
Then
so
you're
just like
out-
logit lens, this still only gives us one token output, right? Well, I mean distribution
Yes.
of tokens, but still.
Yeah, it's
later
a
in the
distribution
paper, they do some edits where you have more tokens, maybe tuned logit lens parallels as well. I don't know. I don't know, Victor, what you said there, like, because it is it is how you change the
Yeah, I'm just saying that. Okay, so you have this D model by D model matrix is
yes
for each it's basically for each component of the model how each other component of the model affects it.
Of the layer. So
yeah, okay, but
so it is a map from. I see it like it's a map from the hidden layers to the final layer, from the hidden layer to the final layer, and each position in the Jacobian. I'm surprised they don't give the definition there. Maybe it's because you
Here they're saying that
one should know it.
the applying the is equivalent to replacing all subsequent layers with the appropriate length method. Okay, yeah, so you just replace the. Okay, I was confused. I think I understand it.
Yeah, you
So
just remove the rest of the forward pass.
Yeah, it's like the geology dance. Yeah, but
Yeah.
just doing the proper lens metrics, which is basically a gradient approximation of how a change in the activations will change the output towards some specific token. Well, towards each of the tokens, basically. Like for you get a token size output, and it's just a distribution of how much some change will change the tokens. But this is not the actual change. This is a linear approximation. The same way if you take, it's just taking the gradient for each token, basically, like when the gradient of something of the loss or whatever is not the actual causal effect of some change of the model. It's a linear approximation of that. The calculating the actual causal effect requires like some more computationally expensive stuff that we don't do to train models because it will be too expensive.
Yeah. Causal inference.
And yeah, compute inference of final layer at present and future tokens. Jacobian. On news and yes, the relating the current residual stream to the final residual stream, and then you just apply the embedding to get the token size output. Yeah. So the thing, yeah, for the thing that calling the Jalens, they are in some sense not taking the direct Jacobian of a single output. They are doing it for a lot the average of a lot of dataset samples and then applying that on the to the layer.
I'm still confused on why that is not wrong. One minute.
Okay. Yeah, can you try to elaborate more on your confusion, because I also thinking about that and trying to understand it.
Okay, yeah, one moment and yeah.
Yeah, don't worry. Maybe I'll read a bit more in case it there's a better explanation.
I think what may be happening when you're doing the average of the Jacobians is if each prompt, because you have all of those non-linearities, each prompt has a specific linear regime over the outputs for a specific point, and at those points you expect the Jacobian to be large in those like prompt-specific directions, and then by averaging that out over many prompts and many tokens, what you're left with is the directions that are strong. So by averaging, you kind of, it is still a linear approximation, but it's a linear approximation of the strong outputs for many different positions throughout the model, as opposed to having a lot of like strongly linearly approximating like noise, which you would get if you were to do the Jacobian for a single model or for a single token and prompt.
Mm-hmm. Yeah, I think also again, I think it's the thing that maybe Nick is confused by, because it's like activations have like this is actually a non-linear effect. So like an activation has conditional effects, right? Like it only has effects in some situations and not others. But I don't think that's something you can represent linearly. Like the if conditions are basically non-linearities. I mean, you can do them with a ReLU. So yeah, like if you have some activation, it will be, if you only take one step of the Jacobian, it will say that in that context, that activation causes that token to be outputted, but it doesn't. You want to find things that in a lot of different situations will cause that to be output, and that requires averaging, and it's related to the thing you were explaining. Like I guess it's another way of seeing it's just that the non-linear things are also what causes the model to be able to, depending on some other token, make this thing to make some token have an effect on the output or not.
That is kind of what I was meaning, yeah.
Yeah. Or like, as a simple example, you could imagine two vectors that get added and they only get past the ReLU, like they are high enough to get past the ReLU if they get both are present. So like you have an OR gate, and if you look at the Jacobian of the vector of only one of when on some prompt when only one of them is present, it and you have some output that it might no, it won't show that it increases the thing that will increase if it both were there, because the linear effect of the can change it, the only that vector a bit is not changing the output, while with the other vector that gets added to it present in some other prompt, maybe changing it a bit will change the output. So yeah. I don't know if this like resolves the confusion that Nick has, but yeah.
Right now, my understanding is mostly that in the JLens aspect, when you multiply the hidden state by the Jacobian, that you translate the current hidden representation into the final layer's readable coordinate system so that the unembedding works. But I'm still confused. What exactly does it mean? So Jacobian takes two variables.
By the way,
that can exist
I
in a
will
function.
probably say it again later, but maybe people will have left by then. But I think I'm going to, although people can still work on whatever they want, I'm going to make for the hackathon that I had planned for like next month on August. I'm going to make it the official theme, the JLens. So see if that inspires people to do stuff related to that. But yeah. Although,
Yeah, I think that's good.
that's just a suggestion. People can feel free to work on something else. But because I don't feel like people were like that motivated to work on the hackathon, maybe that will give some people ideas. But yeah, going back to this anyway.
So use function.
Let's have the fact that this mostly cautionary, important cautionary. Okay, I think the idea there is that since you are averaging, they are trying to find things that are casually important very often. And yes, this means that if something is only casually important in some very specific situation, it won't activate it. I feel like thinking about it, this might explain some of the properties they found that these JLens vectors have, because specifically flexible generalization, or no, it was yeah. The set representation was value argument to many different rostering computations. I think that this flexible generalization property is explained by the fact that if you are looking for vectors that do this thing, that do the same thing, like have the same effect on outputting some specific token, on a lot of different possible situations, and not the ones that have some that only do that on some example but do something else on a different example. Or, the thing is that like you could have a vector that doesn't show up very well on the JLens, even though it has some very flexible kind of thing, the kind of effect, but it's not an effect that translates to outputting more some specific token. I think they are trying to fix that more with some of the limitations page and on the extensions and that on the things where it's more multiple tokens. But yeah, that feels like as a problem with the JLens that is like specifically looking at the things that make it output some token, and you might have more trouble using it to look at things that are more abstract concepts that don't match to some token. At the same time, maybe there is some abstract token that doesn't effect that mostly the model uses for some abstract some concept. Like I think we have some examples here. Like there was something about math. Yeah. Yeah, here there is this math token, and is there a linear probe? Not really. Well, I mean, it's a linear operation, so you could say that's a linear probe, but it's the kind of stretching the like it's calculated differently than people usually train linear probes. So in the sense that a linear probe is just some linear, matrix multiplication that you use to get some, to get something of some concept. This is fulfill that, but doing a lot of other things that people normally don't call linear probes, you will call them linear probes. So yeah, let's say no. But the thing I was saying that, okay, so this have this math token, right? And it's probably representing some abstract math thing, but like math concept. But I guess you happen to be lucky that it also makes the math vector, like the model more likely to talk about math. So I guess there is like, this is an effect that you might have more problem with things that are not language models. But in language models, usually the model thinking out some abstract concept, if there is some name for that abstract context, make it more likely to talk about it. So I guess you kind of get accurate-ish labels as a side effect. I will worry this has a problem with concepts of deception if like the models get better at lying, and there is some lying vector, like some lying concept that barely ever makes the model talk about lying more. And then you will then do that with this method.
They also there proposed a method based on this. Then when you that you can shape the workspace like stuff such that it classifies as honest and stuff like this more often for alignment.
Yeah, but I think the problem is that if I understand it, like if you are looking at the honest, point in the embedding, in the J-lens, it does just says that there is some activations that tend to cause the model to say the word honest or whatever, right? It doesn't tell you. It could be that as the models get better at lying, the model lie activations that make the model lie don't make it say the word lie. By default, it probably does, but like you could see how as models get trained in a way that accidentally reveals deception, or especially people train against the divisions method, the model doesn't have to do that, right? The same vector that makes the model lie doesn't have to be a vector that makes the lie token more likely in a different context. So yeah. I think in practice with current models probably works, but I think it's kind of not a foolproof method at all. Like if it's a method that if you train the model against it, it will be very easy for the model, I think, like to change. Like it feels like to me like it's kind of a side effect of other things about how the model works. That works at all.
Let's use vectors.
I guess I'm interested in general, since there is some evidence here that there is something like some subset of activations of the model are like working kind of like a Workspace or something. if you can find that with other methods that are not the Jacobian, and
yeah, that's a good point.
To what extent is that some privilege or like separate part of the model versus the J-lens is set up in a way that it kind of finds things that have some subset activations that happen to have those properties, even if internally the model doesn't like have that separation. I guess the ablation stuff might be some evidence that it's not that there is some specific substrate that only that you have those specific effects, but we'll see. Anyway, I think I've been talking a while. Let's go back to looking at the paper. Unless people maybe have some takes or thoughts on the thing, or they're still confused about something about how the math works. As I wait a bit in case people.
I get the math, but I'm still confused that it actually works. I think I'm a bit confused that you multiply hidden states with derivatives, and you get a hidden state approximation back.
So far, this really does sound like Logitlens, but better. So I really don't see why they would bring up access consciousness.
Since they find, well, their justification there is that they found particular representations that seem to satisfy the different workspace stuff.
Yeah, so
if you weren't looking for those representations, then you wouldn't make those claims. Okay, go ahead.
I think that their take is something like, okay, so they use the J-lens, and they found that the things that they look at using the the kind of representations that seem to be activating the J-lens seem to have some other properties that are related to access consciousness.
Yeah, but isn't that the case for Logitlens as well?
No,
I think they compared it with Logitlens there, and they couldn't find it with Logitlens. I think. I vaguely
I
remember.
think Logitlens is in general more of a mess, and it doesn't necessarily have all of the. Yeah, I think if you ablate, for example, the Logitlens, you don't only knock up some of the more like some subset of abstract thought kind of properties, and the model cannot. It's not always the things. It doesn't have all of the properties. I think the Logitlens, but that's. I guess we can briefly go to the Logitlens comparison, maybe. Do you know which section that is, Gurnee? I think I'll keep looking at this one. You can find it in the meantime.
I think it's right after the methods. Yeah. Or it's in there. There's a comparison to related techniques.
Okay, let's briefly look at this
and talk about Logitlens.
Logitlens are pre-embedding. This is connections. Layers. The JL can be understood the principal connection. JL is precisely the. I guess there is some reason here why the Logitlens is not as bad, that since there are residual connections, and the model might want to have something where previous layers try to do some mechanism that makes the some token more likely, and they just in some sense vote for that token by increasing outputting the correct embedding for that token to make it more likely. But yeah. Okay, so the two lenses agree closely in the model's SAS last several layers and the various layer. With the JLS, yeah. So the Workspace. Oh, actually, they're saying that the Logitlens also captures a lot of the Workspace text structures with lower reliability. Okay, so we were wrong.
So we know them about Workspace since ages. Well, no.
I guess the Logitlens stuff. First, people didn't thought of relating to the Workspace stuff, and also Logit lens was just worse, so it was kind of more of a mess.
Yeah.
But yeah.
I mean, the emotion vectors.
I mean, some
with
of
steering
the
vectors, which
workspace
is
stuff is
old.
things that you will have guessed that unless you are too much of a stochastic parts person, you will guess that the models can do some internal reasoning stuff because but to do a lot of the things they do, right? Like
Yeah.
if the model can do some addition problem, you know that it has to do some internal operations or whatever.
Yeah, but I mean, if you've seen at least one steering vector, you already have that understanding.
Yeah.
But I mean, it seems most people don't know about steering vectors' existence outside of interpretability, to be fair.
Yeah, I guess they are saying more specific things though. Like they have like a bunch of properties and somewhat interesting. Like for example, that here there's the thing where you ask something was interesting. I don't know where it was. Where you ask the model to compute something that takes multiple steps while it outputs something else. And so you see the model outputting the other thing, but while it's output the other thing, internally is doing this calculation on multiple steps. Anyway, first the GLA shows math, then calc, then 9, 7 equals, and all that. But yeah, in some sense, this is just a new way of looking at the activations of models that maybe is like a better version of Logit Lens that shows us in some sense some things that we kind of already knew that models could do, but it was like a more vague thing of like combining a bunch of how sparse autoencoder features some of them work and how steering seems to work and all that. You can probably guess a lot of the things that some of the properties will be here, but yeah. But then I guess this is like a more concentrated thing where you just use the J-lens and show that the things that you find will just have those properties without to have to think about all of that. But yeah, I do think I guess that that's part of why I don't like some of the flavor of the paper. Where I would prefer if they made a paper more about the workspace stuff and have so like I don't mean the global workspace theory stuff. I mean specifically the functional. Does the model have some internal variables that it can manipulate in some fancy ways?
I think I'm understanding the Jacobian more now when used in the JLens. It's a linear map from the source perturbation directions to target perturbation directions to the final perturbation directions.
Anyway, isn't the Jacobian
that makes it like readable?
Oh, in principle, this cannot give anything that you couldn't already do with steering vectors. In terms of perturbations to investigate.
Maybe.
Because it's also only linear transformations.
I think I'm getting it now. Yeah, that makes sense. Wait, because you...
Well, I mean, it's linear transformations, but it's different ones, right? So like, I mean, you can call the thing where they do here, where they do this intervention of the jet space. You can say that's a steering vector, but like it is a steering vector. It's just some vector that you add to the model and it changes the thing. I just when the steering vectors paper are getting the steering vectors by averaging the difference in activations between some prompt that has a thing and some prompt that doesn't have a thing, and you can think of this as another way.
This is also taken similarly, right? We were averaging the activations to build this.
Yeah, but you are doing as the slightly different thing than doing the difference of activations. You are like doing the gradient thing on the middle. So I guess it's like not exactly the same thing. But I will say if you're doing this, you're also doing steering vectors. You can also just do steering vectors with the Logit lens. Just do.
Yeah, I was just thinking like this would have the same problem as steering vectors, which is that if your phenomenon is not linearly represented, then you cannot capture it with J-lens either, right?
Yeah.
Although, do we have evidence of any specific phenomenon not being linearly represented?
I mean, there is some of the manifold stuff from Goodfire, and the
I'm
yeah,
not sure if that's the case here.
So then we will need a manifold version of J-lens.
but
Yeah. They talk about
I'm not sure that this
relationship
only
to
works
SA
when
features
it's
later.
linearly represented when you do if you do the average step. And
But average of linears is still linear, though. You know.
Yeah, but let me think. So you're taking. I think I need to add closer about it. But I feel like when you see if you are taking the average of different, but it's like different points. I guess the
Yeah, but you're still using that to calculate a
stream
final
vector
linear
is
transformation, right? So
yeah. I mean the intervention will only have the effects that you can have with linear transformation, but I need to think about more about that. I don't know.
Put the activation into an unbending compatible coordinate system. I think that makes sense. But I feel like there should be more to it. What am I? How? Why can you even do that? Because it's the derivatives.
Can you do what? Sorry? Also,
In
by the
the
way, isn't the
J-lens.
Jacobian just the like is the partial derivative? So like, is it
Yes.
is
Yeah.
this the same as just taking the derivative for each token from the activation?
it is. Yeah.
Okay. I feel like I that just like since I like that's a simpler way of thinking about it than me for me, but I guess I just need to get accustomed to the Jacobian like I guess the Jacobian is just the like the gradient but for more dimension more than one output.
Exactly.
Right?
Yeah. How much would each input change each output, basically? Yeah, if you have vector input and vector output.
Yeah. And this is just so this is just in some sense doing logit lens but taking the putting the gradient in the middle. Which in some sense like seems like it as an easy, like a simple thing, but nobody thought of it before apparently. And I guess it makes sense. And it's interesting that it works better. There's definitely stuff about non-linearity. Maybe we need the manifold version or something.
Like you know why it works better, huh? You know? Do you have intuition there? Why it works better when you multiply it by the Jacobian?
Okay, so I think I have an intuition, which is that it's the thing that is saying that I think people already say it on the chat, which is that the with the logit lens, people try to use the tone lens, but they get to that. So the logit lens, you're only looking at things that happen to be aligned with the output tokens, right?
Well, in logit lens, you don't know if it's aligned with the output. Like you're
assuming it, right? You're trying to look at activations that are aligned to the output tokens.
Yeah, you're assuming you're speaking the same language basically in the middle layers as in last layer.
Which is false.
You can try to do the tool lens, but the tool lens is doing optimization. It kind of can't basically be good-hearted. And this is a more principled thing where you are trying to find the activations that cause some output token. It's just this doesn't assume that the output token, that those activations are represented in the same way as the output token.
And when you multiply it by the Jacobian, you
linear effect
make
on it.
the And when you multiply by the Jacobian in the lens, you transport it from the transport coordinates that are more aligned with the unembending vector readout.
Pretty much, yeah. Like you are assuming that the Jacobian is your way to basically translate from layer 5's, let's say, vocabulary to last layer's vocabulary.
Yeah.
And LogicLens assumes that you don't need to translate; it's already there. Yeah.
And even the LogicLens already sometimes works. And
I would imagine it should, because I mean, every MLP block is only just slightly perturbing the residual stream, right?
Yeah.
Like because of the residual connections, it mostly remains the same. So especially in later layers, it will make sense that it works.
Yeah, and it makes sense. Like also in some sense, some circuits want to increase the probability of some tokens. But like it didn't need to, like there is not some guarantee that it works, but it happens especially apparently more with the Jacobian lens that it corresponds to some nice properties of the, especially when you do the averaging. It corresponds to some motivations that have some nice property, like it happens to have some nice properties to looking at what the model is doing internally. And it didn't have to be the case that the kind of activations that make the model, I don't know, output the word mass happen when it's thinking about mass. It kind of makes sense why that will happen. But like it's not like a property of like that transformer detection. It's just like what happens when you are training a model on text such that, you know, when it's doing math, it's more likely to say the word math or whatever. Well, there's also, to some extent, there is probably a lot of other things that are less related and kind of don't work that way. And we're just looking at some examples where it happens to have some nice meaning. But yeah. And yeah, it makes sense that when the model is doing some intermediate operation that uses the number 42, it will be more likely to say the word 42, especially if the model does in fact have some kind of verbalization capabilities where it can sometimes talk about the things that is internally, the internal variables that it is using, or at least some of them. So so that if you ask it what are you thinking about, it will tell you like the operations it's doing or whatever. But I guess this means, like, I feel like this is related to the Jacobian lens working better when the models are better at verbalizing its internal activations, I guess.
You mean for chain of thought models?
I mean, yeah, like small models that when they are doing some internal operations, at least for some subset of them, they have the capability of, you ask them, what are you thinking? And they answer correctly, or with something that's at least vaguely related to, you know, if you have a model that you make it do some math in a single step, and then if you ask what operations did you do, it will answer correctly. That will make it the J-lens worked. Whether if you have some model that has a bunch of internal activations that it never, like it uses, but they never come up like explicitly explain what it's doing on the explanations don't match at all what it's doing internally, you are not going to find it that much. Like it's going to, the JLS is going to work worse at being in some sense a way of looking at the model is thinking in quotes. I think. Also, okay, Catman is saying something on chat, let me read it. What if it's that when we look at the output of the J lens, we observe the tokens being between estimate the name of the word manifold that works for that token? Your direction is still better with the model version already within a small distance without manifold. Yeah, I'm not sure what you are trying to say. Can you rephrase it or something? Or tokens? Like which tokens that works for that token? Oh, that will make it output that token or something? Yeah, sorry, I'm not
So
sure.
what I'm trying to get at here is kind of more what I was talking about earlier, where using the JLens as a steering, I don't think really works because what it's trained for and what it's trying to find is it kind of like moving away from like going towards like the manifolds thing is it's finding these spots that already exist within a specific manifold and having low values there and aiming towards that indicates that you're not towards that manifold where the kind of regime that it's capturing works.
I mean, so it seems like the steering kind of works sometimes. I think with the manifold stuff is that if you take even if something's represented as a manifold, if you there is a thing with the sparse encoders where you can take a bunch of lines and they like maybe some concept, some manifold, but there is a bunch of tokens that are pointing to pointing linear directions to different parts of the manifold. So you still detect it, even though your method is kind of missing the actual structure. I don't know if I'm explaining myself very well here.
I think I get it.
Okay. I guess we could go to the. I guess we went here a bit. We could go to how well the different.
There is also JSpace.
The other
That's another
experiment.
math.
I mean, isn't the JSpace just the things that activate the JLens or something?
I think the JSpace is interesting. They define
Okay, let's
what
see
exactly the
how they
workspace
define the
is.
adjustments. The JSpace vectors from a completed set. Tempo cap vectors in the model dimension still spread with cap bigger than the model.
But like, what?
Expand the
I'm
entire
still
residual
confused.
stream. Okay.
Why?
So,
Why would multiplying by the Jacobian would necessarily be aligned with the unembedding vector? I'm still confused about that aspect. Like, why would it do that in the like? Why? I
okay.
get it, but don't at the same time. It's confusing.
The Jacobian's like the similar part from all the different layers, right?
I mean, but you are multiplying the Jacobian by the you are doing the Jacobian of the last layer and then you're multiplying by the embedding, right, to get the.
Yes. If the Jacobian matrix would be identity matrix,
Oh,
it
like-
would be just like that because
How would this work? Like, let's say
Yeah.
you take a Jacobian of the last layer and the embedding. Like, couldn't it just like detect the thing that's similar from for example, like the language is English and just takes the most generic info, or does it actually? How does it work?
they don't take it. They don't take it with respect to embedding, or you mean multiplying after in the lens JLens? The Jacobian is always Jacobian of the last layer with respect to some layer of interest.
I feel like there's stuff in the
I'm not
earlier
sure what
layers
this
that are
is.
not in the last layer, though.
Well, you could look at how
but
the different layers influence each other.
But as long as the stuff on the early layers will have some linear effect on the stuff on the later layers, you can find it with this kind of thing.
Mm-hmm.
Like if you do if I think they wrote there somewhere that if you take it like in the earlier layers, they found like low level stuff like I don't know syntax for instance. In the
Yeah.
later layers, they found these reasoning stuff which are like the workspace stuff. If I extremely
Yeah.
oversimplify it, and in the much later layers, you're much closer to the output, like doing the final refinements of the what to actually predict. I think
Yes.
that's what they mentioned as well.
I feel like linear is kind of an assumption with things like attention residuals. Papers like attention residuals from Kimi.
There is no unique way to decompose a given activation vector as a linear combination of J-length vectors. Okay, that makes sense. Because there is a bunch of positions. Empirically, only a relatively small number of J-length vectors are strongly active at the time. What is a J-length vector here?
I think it's the Jacobian times the hidden state. That's the vector. So hidden state transferred by the Jacobian,
Okay.
which I'm trying to reverse engineer now, more semantically. I get the math, but the semantics feels weird. We should add in a LaTeX bot here.
I'm also asking Claude questions on the other screen.
This is when you fully expand the, well, it's not completely fully, but this is, or it is actually, when you expand the multiplication of the Jacobian with the hidden layer. It feels more understandable for me when I expand it like this. It's more explicitly. And this is for each like I. So the Y is the last layer and H is the hidden layer.
Alright, since the J-length is since the Jacobian is linear, you get some vector of activations that increase the, like you take the gradient and that gives you an approximation as a vector of the activations, original activations. Okay, I think I understand that. I was a bit confused. Like you
Makes it a
take
bit
the
more
gradient
complicated.
of something, you also get a vector of like
Yes.
of that layer.
Yeah, the matrix multiplication is transporting the hidden
But
vector.
this doesn't have to align
to
with
the
the
last layer
features of
vector.
the model exactly. But I
Like,
guess if you take those vectors and you try to average them, you'll get more the vector that is only for that concept or whatever.
Like it seems to be aligned with the unbending vector matrix. If you do this, you make it more aligned with the unbending matrix. So when you read out, you get more sensible answers. That's my understanding of the Jacobian right now.
Okay, so I'm going back to the thing that Nika was saying earlier. So I heard this is basically like stealing vectors, but you are doing it on, instead of on the activations directly, you are doing it on the gradients. Right? Instead of average of activations, it's average of gradients for that token.
In the J space,
I'm talking about the vectors, the J-length vectors, right now.
And when they
I still haven't figured out the J space.
J space coordinates in order to the steering, you have to see the J space. You patch it by adding to the hidden state. What is V? I don't know what is V.
Okay, only a relatively small number of J vectors are strongly active at a time. Therefore, okay, what does it mean for a small number of J vectors to be active? I guess I don't
that they are non-zero. So we need to do this
If in this
multiplication so that the
if they
the
are
causal
variants.
influence.
I guess you just take the you take the vector and you just project to it. That makes sense.
I think by active that I understand it's just not zero.
Claude said it's just the inner product. You just how with the activations.
Activations with what?
Like
Inner product.
you take the activations, you do the inner product with the J-lens vector, and that's it means for it to be active.
Oh.
So they are saying that in practice for some set of activations they align with a small set of vectors in J. Like if you project the activations to all possible J-lens vectors, like for all possible tokens, you take the vector that you get from averaging the gradients for that example, then only a few of them work in some sense. Like only a few of them are activated.
Yeah.
No sparsity level K.
Aristotle saying it must align better with an embedding. Like you have to assume the linear route.
Let's modify the visible variance by layer, but never more than 10%. Okay. Okay. So they have some sparsity. And we have some small sparsity. For attention space. Dimensional cones. Okay, I'm curious what this J space is. Okay, so with the J lens you can just get a token output, right? You don't need to do this J space thing. I'm curious what this J space thing is doing. Right, because otherwise you just take the average and see which one is the...
I'm also confused. They use the word cones there and they don't define it.
I think it's cones because you have a bunch of directions and it's like the area between the arrows.
Yeah. Why would you use that word? That feels... I don't know. Yeah.
But yeah, they're doing this sparse decomposition thing.
Yeah, I think I'm confused because in the figure 4, where they show the map visualized on top, They use the word. They use V. V is VR V Mars. V Mars is an embedding Mars Jacobian. What is Mars? It's just activations.
Okay, so I guess the problem is the okay. So what's the problem? They are saying that the number of possible tokens is too big, so they are trying to find. Yeah, they're trying to use some sparsity to find some combination of vectors that reconstructs the activation to say which vectors some activations are activated instead of doing the just take the inner product thing.
Why are they taking permutation of the coordinates when patching? Why is V taken V? I am so confused by this picture in the figure 4.
Okay, figure 4, where is that? Figure 5.
Yeah, here. Like the C part. So H is the hidden layer activations.
Yeah.
Then you multiply it by V transposed. V transposed is VRV Mars.
Oh, but
in the
this is,
product.
they're trying to replace Earth by Mars, right?
Yeah. So they are doing a dot product between. Okay, and V Mars is an embedding of the Mars. Is Mars activations?
No, I
Multiplied by
think it's
Jacobian.
the. No, I think it's the. From the J space vector, like it's the.
Yeah, the most right equation. The V Mars equals. That's the V J-Lens equation. But instead
yeah,
of
like
the hidden state, you have Mars.
adding the Jacobian, like it's the activations that cause Mars, the embedding of Mars to increase, like with a
So-
linear approximation when you take the gradient.
So yeah. So Mars here, if you just look at the word Mars, is just the activations corresponding to Mars.
Yeah, just the gradient of Mars. You can think of the gradient of the Mars token, basically. I think, like it's not
It shouldn't be
exactly that.
gradient, no? Because in the equation, that corresponds to the hidden state. Also, there's no normalization for some reason. I guess they just skip that. If you go to the J-Lens, you have the J times H. So, also, why is the J on the right? Because matrix multiplication isn't commutative. So this is something else. I'm so confused by this. This feels wrong.
I don't know.
If you look at the lens,
Maybe you can copy
you
paste that
have.
formula and into Cloud and ask it.
Yeah, maybe. You have the hidden state L.
Yeah, okay, I
from
get what you
the-
were, because this is the W Mars and then it's multiplied by the JT, and here is the other way around.
Yeah. A matrix multiplication isn't commutative.
Oh no, but here no,
Is
but
there some
no, it
source
is
for that?
here it's W multiplied by J on that order, right? It's just not doing the normalization. It's just the. Oh, but okay. No. This is the same operation, Gurnee. You know why? Because this thing is being multiplied by, like, W Mars is being multiplied by
View takes in
no,
Mars.
wait. So on here they are here it's W multiplied by J multiplied by H. But here you want the vector. You don't want to multiply by H. You are projecting, so you are multiplying by H anyway. Right? Well, no,
There's H in that equation. What does Mars mean?
No, this is just the Mars. Here, Mars is just on the unembedding the Mars token. Like it's like Python indexing for notation of like just using Mars as a on the W.
You are unembedding a token? That also
No,
doesn't
this
make
is
sense
the
to me.
vector on the unembedding corresponding to Mars.
Oh.
And it's multiplied by the Jacobian transpose.
Oh. Why? Alright. Why is it notated like this? Why isn't the Mars on the bottom or on the top or something? Alright. Yeah, that makes sense. That makes more sense. Why is there these brackets? Okay. Oh, Jesus.
I mean,
okay.
I don't know.
Unembedding of
I
Mars
understand it immediately because I guess
multiplied
I
by
have just programmer
Jacobian.
brain.
That would make sense, I guess.
Yeah.
So the unembedding of Mars. That is. Wait. Yeah. That is then multiplied by the Jacobian. Okay. So you get it to the J space. Mars, Earth. So V is. And what is V then? What is this notation? You have these brackets again. Then you have V Earth, V Mars. So those two are vectors. So are you doing a dot product? Why is there no transpose? Shouldn't it be V Earth times V Mars transposed? Or dot products did? Also, is it?
I think it's multiplying P by this swap thing. You should probably just go find the section where they explain that and not spend that much time looking at.
Yeah, maybe. Writing. Here they are explaining it. In the writing.
Let's go to the. Yeah, I was also saying.
Detail.
Let's see the technical details of GLA's use cases because I was completely confused by that stuff the earlier thing. So yeah, how did you just the first readout? All layers of HTML with single linear map. Yay, produce a lens. So you just do the softmax things. A scoring for every recoverability. So this is the simple thing. I think we are I at least more or less understand that. You just take the Jacobian, multiply the activations, normalize and multiply by the embedding to get a token size thing. So you just this is just the thing that's equivalent to the logit lens, but also no, Sam. We are looking at the Anthropic paper. Yeah, that was going to paste it, but that one. Okay, so this is the parallel. This one at least I understand because it's just the same thing as the logit lens, but you add the thing where you calculate the Jacobian to make it like better. But it's kind of think of the same kind of thing as the logit lens. Because the previous slides are
concept activation and to break concepts or out an activation.
With a general vector, the same machinery can be used as a per token probe. We did the score as a single chosen PT without ranking the full vocabulary. From measure where specific cost is presented over threshold. Okay, so they can also calculate the
Right.
activation for a single one instead of the full thing. When we need a discrete inventory of active concepts at a rank list, we use a sparse decomposition. That's the JD space thing that I understand less. But okay, so
What is the VT again? That's the
so when they want. So the J lens just gives you a score for all possible numbers, and it's just some number from 0 to 1. But they want to do something like sparse encoders where you have
the one
some
vector.
sparse subset of J-lens vectors and say which ones are activated in quotes, and that this has problems that.
Okay, they do inner product to see how the different J-lens vectors are similar to the hidden state.
And I guess they basically have some reasons earlier they explained that because if you try to do something like just it wouldn't work as well if you wanted to do something like what the like just take the say that the ones that have more than some value are activated. Instead do this sparse decomposition thing. I guess like the problem is that there is a lot of vectors and they overlap a lot. So yeah.
Each J-lens is the direction in the residual stream space, so it is before you do the Jacobian. So J-lens vector is the hidden activations before you do the Jacobian.
Okay, I think Claude has a point here. So the thing is, if you do the naive thing of just, try to find which vectors are activated by taking a bunch of, doing this inner product thing for a lot of different tokens and just taking the high ones, that's not going to work well because there is a lot more tokens than directions in space, and a lot of vectors are going to overlap. Claude used a nice example, which is if you have some orange.
Is that true in general? Yeah, I guess. How many tokens are in the normal vocabulary versus was the dimension that it was space?
I think it would be very weird that vocabulary was smaller than the
probably.
the model.
That's
I
true.
don't think like the vocabularies are on thousands of tokens or more.
Yeah.
And if I don't think any model has like 10,000 D model or something.
Yet.
Yet, because the number of parameters is increases exponentially when
Yeah. Okay.
you get D model multiplied by D model
Yeah.
parameters when you have on the MLPs. So yeah.
So Jalen's vector is a direction of the stream associated with a single token modulus vocabulary. So is it constructed by finding a vector that is the biggest number?
Okay,
in
so the thing is,
vocabulary after you do the Jalen's?
you mean the Jalen's vector? Okay, so when you do the Jacobian and you multiply by the so the Jacobian multiplied by the embedding has rows, has vectors that on activations that most activate that vector. You know, like if you take the gradient of some of something with respect to something, you get some vector, and it's just that. The thing is, the problem with that is that there is too many of those for all tokens. So when they want to do like have a list of vectors that are activated, if you Cloudpulse gives the example of the naive version where you just multiply all of the possible vectors with the activations, and that's the problem of, for example, when you activate something that activates orange, probably also activates other fruit, or lemon or whatever. So you'll probably overestimate the concepts. So they try to do how many concepts are there? So they try to do this sparse decomposition thing to try to find the smallest set of vectors that you can use to, reconstruct the activation.
Yeah, as the J space.
And yeah, that's what they call the J space thing. It's not what I thought from skimming stuff was the J space.
Oh,
never mind.
But the J-lens vectors are more general, no? Those are like... Yeah, form an overcomplete set.
Okay, so writing, and this is the thing you were confused about earlier, which is, the simplest intervention is steering alongside a J-lens vector.
H, A, V. So A is some steering strength, V is the vector.
Yeah.
Oh, so the Mars is like some token. Huh.
Yeah, those I say.
Applied at one or more layers and token position. Oh. Patching in length coordinates.
Okay, yeah, that's the thing you were confused about earlier. So the second
Given a source
intervention.
token S and a target token T, we form Apple? What is this notation? Matrix SVT. So concatenation. What is that operation? Read the length coordinates V.
The lens combination.
We are trying to inversify it. Alright. Do the inverse and set H patched H plus V. Swaps to 2 entries of C. He has 2 entries. So it's just a vector then. But like VS, that's a vector. Do you mean This is a weird notation. Do you understand the notation? Like what V represents, for example? V
I'm using the
equals...
magic of asking Claude. what the notation means.
I think I'm overcorrecting now to try to use my brain too much.
I mean, I feel like
Yeah.
reading notation is probably the kind of thing where it.
It's a matrix of 2 columns. By usage in the chat. A matrix of 2 columns.
Oh, okay, so yeah,
Yeah.
it's he's saying Usagi is saying it's just concatenation.
That was one of my thoughts. No, this is not a concatenation. Well, it is a different form of concatenation than I imagined. Okay.
Okay, yeah. So yeah, it's concatenation like it's you making a matrix of 2 columns with. It's not. It's some operation in Python in PyTorch that I remember the name of, but yeah.
Yeah.
Where you take you have the vector and the vector is like this and the vector is like this, like they are pointed to the bottom. So yeah, they take is taking the vectors as columns. Okay, so yeah, it's geometrically it's just this, Gurnee. Like it's making this thing.
So
Like like this making this like 2D thing with the 2 vectors as
they swap in the sea. So and in the equation h plus v,
kind of lost a bit.
why is v taking as an argument c while c is defined by v? Isn't v already defined on top? Why is it taking one argument? Isn't it matrix? Why is a matrix taking an argument? What the hell?
Maybe you're multiplying.
Like if you look at a patched equals h plus v, suddenly v takes an argument, or so, like.
Oh no, it
there's
doesn't
like-
take it can be just multiplication. It's multiplication. This is just multiplying by
Oh.
the root of.
Yeah, okay. Yeah, that would make sense.
Yeah, I think you're getting confused. And also, I mean, you can see a matrix as the matrix multiplication as the matrix taking the other thing as a. You can see the matrix as
Well,
a.
in this context, if you would take it that way, the order would change. I think, if I remember correctly.
But okay, so you. I'm getting annoyed because someone else is.
Because you're multiplying the matrix by the left one, not by the right one. Yeah. Okay. So you step in the C. Well, C is the pseudo inverse of V. Okay. So pseudo inverse. So you have. So I have the hidden state. You multiply it by the J-lens vector corresponding to.
The thing Rowan is claiming here is that so the thing you are doing there is replacing, like doing the thing on the image, which is you are replacing. You take the this is just a fancy way of you take the Mars vector, right? And you try to just swap it so you have a new activation where the thing has as much, like it has activated on like you swap the amount of Mars versus vector by the amount of Earth vector.
Yeah, that makes sense.
Like if you could think of the activation as 0.5 Mars plus 0. Like I don't know, 0.6 Earth, you make it the other way around.
Yeah. I get the intuition, I think.
It just has to do fancy math. I think it has to do the slightly complicated math, and it has to do the pseudo inverse thing because the Mars and Earth don't necessarily are orthogonal. So that makes things more complicated.
Yeah. V is an operator from R to RD. Yeah.
And
And so
this thing is just a
plus
weird
is
way of
operated
having to
from RD to that's the. I think you mean the pseudo inverse. Yeah, okay, the plus, right? That makes sense. Yeah. That would be the pseudo inverse. That would change it. So C, I think, is the projection onto span of V source and V target.
Yeah, I think that makes sense.
You take the H.
Yeah, so this B multiplier thing where this operator swaps the two entries, this is just a fancy way of saying you take the how much you take the amount of some vector and the amount of the other and swap them.
Yes.
Okay. So I guess the next part is the J space as a global workspace. I think so we already said we were going to not talk about the philosophy stuff, but I think this is interesting. Like this is mixing the functionally seems to have some interesting properties, the things you find with the Yellen stuff. So I guess we'll look a bit about that and try to swap the
But why are we collapsing everything?
Global workspace theory.
Yeah, but why are we collapsing everything to just 2 dimensions?
I feel like the problem is there's probably a terminology problem where I think on a literal reading of global workspace, like global workspace theory, the brain is a very specific thing, but there is like if they have called this global workspace without talking about the brain stuff, I would have interpreted it a different way. They're just talking about some internal scratch path, you know, in the model.
Yeah, internal. I think this. I'm not sure if I get your point exactly, but.
Okay, never mind. Let's just read the thing because I feel like otherwise I'm going to get into that too much.
Okay.
And, I think we can read the thing and then I can after that in my takes because with the model it's interested to think. You can completely ignore the philosophy study and think about what does this tell. What do they find that the properties of the J space variables are? Well, actually. No. What do they find about the properties of the J space variables on some specific layers? Because it doesn't happen on all layers. And I think this maybe relates to some subspace of activations that have some nice properties, and maybe we could find it some other way. But let's get into it. So, Jacobian lens is. Also, people feel free to say stuff if you think I just getting distracted or saying nonsense or something. Or you don't understand what I'm saying or something. We begin with a simple example in which the model is instructed to think to a specific category. Okay, so this is the well report thing. Before. We already said why it makes sense that like the kind of this the J lens is constructed to have this property. Like some says it's trying to find an approximation of this property with the gradient.
It's constructed to confirm the theory. I had some thoughts about it. Like it feels like the whole setup is constructed such that it finds the workspace. Like not fully, but like it's in this direction.
I think there are some things that maybe. Well, I'm not sure. What's to it? I think at least this one is one that the this one is definitely the one that the setup is constructed to find the most, because it's literally optimizing for doing a gradient to find the thing that makes it say the thing the most. Well, not just because it could also just immediately say the thing. It didn't have to be more on the long term ones, but yeah. Extract proyectan onto the soccer lens and add equal magnetic project to the Ruby lens, and that makes the model output Ruby. Okay, that makes sense. Category concepts. This could fail if, like, some things were not had non-linear effects or whatever. But yeah, it probably does, but it fails at some point. But yeah. Find that the ordering of the reported words is in the typically highly correlated with the ordering among the lens token. Once the end of the gospel, the model is closer to produce the next token. Okay. That makes sense with how it's the linear approximation, and the closer you are to the end, the more like the embedding it becomes, and the less linearities there are.
I agree. Yeah, it makes sense, kinda.
It's not
I find it also like the whole thing here is that you are trying to take the whole residual stream, you pass it to the coordinates of the last layer, then you do the unembedding, then you take the softmax. Okay.
But you are doing the Jacobian, right? So that does give you the gradient through all of the layers. It's just that the gradient through the layers is like a linear approximation of the.
I'm more thinking that. Yeah, I guess I'm thinking about superposition there. Like, I guess if the residual stream was doing some, like, in the middle, some computation in superposition or something, and you will get all the different tokens that are. It could in parallel think about dogs while calculating a math problem, so you would get both in there in the logit. So you would get 50% dogs, 50%. I don't know.
I mean, the model definitely has a lot of superposition. Even without superposition, you could still think about deep model concepts, but you can think about more than that.
Okay.
Also, I see Deckard is unmuted. I wonder if he's trying to say something. If you are talking, I'm not hearing you. So.
Sorry.
Okay. You didn't. No, never mind. I was just. Don't worry. You can be unmuted if you want. I was just wondering if you were trying to say something. But yeah.
So I just asked GPT, and for context-dependent stuff where on average cancels out, JLens would completely miss that. Like, for example, you can see that if, let's say in your layer some L, there is some element in your residual stream that half the time increasing it increases some tokens likelihood, and half the time it decreases some tokens likelihood, depending on context, then on average your JLens would say that it has no effect at all. And so you would completely miss it.
I think that in practice you. Sorry, what were you
going to say? Again?
So the thing he's saying is that if you have a vector that, like if you have some activation that in half of the context increases on token, in half of the context decreases the token, the J-lens is going to show no gradient for it, and it's not going to show up. Right? Is that correct?
Yeah. Like it might actually be hugely important, but on average,
What do you
giving
mean by
zero results
context?
because of
You
the
mean
yeah.
you mean the
I
context
mean,
window?
for example, let's say context can be like very easily where we are in a sentence about negation or something like that. That's the simplest case I can think of. Like, is
Why
this
would it not
happening or
detect
is
it?
this not happening or something like that would be
Yeah.
one example of
Why-
that. But maybe even in just different conversations, you can
think-
imagine that. Yeah.
But
I
why
think
would
the
it not
thing-
detect it?
Or he's saying that if it's negation, and you imagine some examples for a lot of tokens, it will, in some cases it will cause it to say something, and in some other cases it will to say the other thing, right? Like if you have some programming language thing that with some operations, and you have some negation symbol, and in some cases will increase the probability of, if half of the time increase the probability of true and half of the times decrease the probability of true, it will cancel out and show no effect on true or false. With those, it has huge effects. It just have different effects. But I think the reason why that's not as much a problem in practice is that it will still activate probably some negation token. Right? Like,
Yeah.
as long as there is some some token where it activates your abstract concept activates it most of the time. Even if there is this means that you are not going to the thing that's unreliable is how much the vector is activated or something for some token or whatever, but the other way around, you still if there is some important internal variable or something that shows up in something, you are probably still going to see it with the J-lens because it's probably going to activate some token. But I don't know. I don't think this is necessarily true always. But yeah. But I guess in general, if you have some concept that doesn't cause any token to be more likely. Okay, yeah. I think I wrote an example on chat. Okay, what animal is this? Answer the correct animal. Is this not? Answer the correct animal. No, so I'm saying that the not thing will make it more likely to output things like when you ask it, does this sentence contain a negation? It will make it more likely to say negation related words.
Yeah, but I mean, you would not know what concept got negated, right?
Oh yeah. So, but so the animal.
But I mean, yeah, this
But
assumes that there's
that
roughly
only
an
works.
equal
That
amount.
only
Yeah.
happens if in your entire data set it
There's
has
an
more
equal
or
amount,
less
yeah.
average. As long as you have a varied data set where your thing for some token it makes it happen more often than not. It will probably show up for some token.
Yeah, you're right.
I do feel like there is something here where this is not a reliable method to like actually estimate the effect of some activations on the output.
Yeah, I agree, because you totally miss the rare occasions. Like, let's say 90% of the time, this element in this hidden layer is used for some task X, and 10% of the time it's used for an opposite of it. It would completely get dwarfed and you would not be able to tell. Yeah.
But I think a lot of the examples of what they use for are kind of the opposite. They're kind of trying to find the elements by looking at the things they activate. So they, I don't know.
Yeah, but I'm saying, like, if most of the time that element activates something, the opposite of it, basically. But sometimes it
Yeah.
activates it in the opposite way, in a way that, let's say, matters for safety. We would miss it with this.
That
Yes.
makes sense. I think, yeah, a lot of concepts in practice are like there is a lot of possible tokens. So there's probably some token that it activates more.
Yeah, you're right. I mean, that
than
would.
the other.
Yeah. I'm kind of
But
assuming here that
if
the
you, for
entire
example,
distribution of tokens would be reversed, which is less likely. Yeah.
if you wanted to do something like for this specific token, does this specific activation make it higher or lower? This kind of method wouldn't be very good. But if you just want to do something like use token, this aliens thing the way they are using it, that probably doesn't matter much because you just want, you're trying to find, in some sense, like use the aliens to find that concepts, and as long as there is some label that happens to be increased by that token, by that concept consistently, it's okay.
Yeah, but what I mean is, we would probably upgrade on J-Lens a lot if we made multiple context-specific J-Lenses and used the one that seems most fitting instead of having one global J-Lens to avoid this kind of averaging out effect.
That makes sense. This is also related to the previous thing. I gave an example, I think, before you joined, of a case where I think it wouldn't show up, which is, imagine there is some concept that makes the model lie. But I think currently this will make the model also more likely to say the word lies or something, and that's why there is some example here where they catch the models that way. But if you imagine models that become much better at lying, maybe there is some internal lying thing that never causes the model to admit that it's lying or whatever.
Do you mean if literally during the training process the model can see its J-Lens? Or even without
That's
that?
a way that could happen. I mean, it could develop in a lot of ways. But if you, for example, train the model with the J-Lens, I think it could be very easy for it to learn that, to have some concept that doesn't show up in the J-Lens. But like, okay, so for something to show up on the J-Lens as, you know, increasing the lies tokens or whatever, the model has to be bad at lying, because it has to, when it has the lying internal concept, it has to be more likely to say lie-related words than otherwise. So you could also catch the model lying by things like asking it to if it's lying, or asking it to talk about deception or about random things. I will talk more about deception.
Yeah, I see what I mean.
So if you have models that have some internal scheming that is very good and they don't reveal in barely any circumstances, it's not going to show up in the aliens at all. Or like it's going to show up with some random word that is not related to deception and you don't know how to interpret. I don't think this is a problem with current models, but if you, for example, made the mistake of training the model with the J-Lens, it seems to me that it would be hard for the model to like. I think actually that will train the models. But there's probably, if you wanted to make a model that's really good at deception, there's probably a good method to do it.
Yeah, I mean, in that sense, this is similar to training on chain of thought to avoid mentioning the line in chain of thought. but like one layer deeper, basically.
I think this is worse. You're trying to make a model that basically never says the thing when it has that, never says the lie token or something. But you probably need to do something like average it or something, because I guess the naive way that I was thinking probably just makes the model never, like, you can catch the model lying because when it's lying it doesn't want to say the word lie. But yeah, you could do something that seems like it's easy to fix with math.
Oh, by the way, see the image I uploaded. It's from this paper, I believe.
Okay.
Yeah, I think that's also in the paper. They have some damn examples, so I think that's directly from the paper.
Yeah. I mean, we'll get to that once, but I think that's interesting. Yeah, I think need to look at it. I guess we got sidetracked talking about this stuff. I guess we can go back to the verbalization stuff. And okay, so there is verbalization. I think we already talked about verbalization. I just jump in the verbal reports. I think this one is kind of trivial for reasons we already said. That the J's lens is constructed to maximize it in some sense. But okay, I guess that have a point that since you are looking for that, then you have some small amount of some small percentage of some small subspace of the activations that like the J space component of the activations is like the part of it that makes the model talk about the thing.
Directed modulation.
Yeah, so this is like another thing. It feels like this kind of. It feels like to me that maybe you can make a really good method to maximizing misalignment or maximizing the third thing, which is really bad.
What?
Maybe it's
The
a model
second one?
organism. By using this to train a model to have the same performance in lion-related things, but never say it, like never verbalize it.
Oh yeah, model organisms
Yeah.
of misalignment. That would actually maybe
You could do
be
that.
useful.
I need to maybe.
But probably you should like at some point you
good.
ever wonder like maybe some studies should not be published so that they don't end up in the training data.
This should be contrastive
Yeah.
loss.
Like maybe just entirely ban less wrong from training data or something like that.
I have that thought.
Yeah, I don't think that
often.
will work because it filters on the entire data set. It's not like you can go and be like, you can only to talk about this stuff on less wrong or whatever. You
Yeah,
could
you
have a
have to
global censorship regime.
yeah.
Also, I think at some point as the models get better, they'll kind of get suspicious if the a lot of the the training data conspicuously doesn't talk about certain things. I mean, and there will be people talking about the fact that it's not that they are moving it from the training data on Twitter anyway. So. But yeah, I guess you could filter the data better though. Just use some LM to find all mentions of something and remove it or whatever.
I feel like a lot of this can be changed a lot by prompts in the training data and the sparsity of the jail space.
Okay. So I think this one is less trivial. It makes sense that saying something makes it, more likely to do the other thing. But I think there is some less. It's still kind of not that surprising, but this one is less trivial than the verbalized one. That I can imagine J-lens versions that in models that wouldn't have this property always.
Yeah, the car posted in the chat.
I mean, for the
another
first one, I
paper.
could imagine a way they could not be true where it like it only works for the immediate ones. The average works for the immediate ones and it doesn't work well for the long-term ones. But yeah, that's okay.
Yeah, the car posted in the chat how misaligned training data in pre-training causes it to be more misaligned.
Yeah.
I think I've seen like 20 or 10 or something papers saying the same exact thing.
Yeah.
I guess the scary thing is the pure reinforcement learning optimization, for example, is different. Yeah.
Just leer sendo depends both the imaging content, representation of the other imaging it. When the final layers, the layers read switch to predicted and output token.
By the way, Bernie, about that. So Dario, in his recent Adolescence of Technology post, says that he no longer worries about paperclip maximizer kind of scenarios, but now he worries that the LLMs we create might have psychopathic personalities and, yeah, basically act like evil people.
Yeah, I think I've seen that. Maybe because you posted it. Yeah.
Yeah, I don't think that generalizes as the LLMs have increasingly more optimized, and with RL to solve problems instead of just pre-training on text. Even pre-training on text, I think, in some ways where as you get more capabilities, you can start having the model.
One day maybe we could trap the models into a persona space on purpose, like clamp their activations in there or something like that, such that no amount of RL makes them, different from people.
I mean, there's probably some trade-offs here of with capabilities, which will mean that the people who do this
No, I'm
make
not
a lot
sure.
of
Like,
money.
if you buy the orthogonality thesis, I mean, I don't know if you buy it, but if you buy it, there should not be any capability trade-off from that.
Oh, but I think, I think the problem here is that you cannot, you will have to fix the human, only the human values or whatever, without, without changing the other, while changing everything else about how it's more human-like
You would basically
changes.
block the trajectories so that even if the destination points exist, you can't reach there, basically, or
I don't
can't reach there as
think
cheaply. Yeah.
that doesn't seem like it's necessarily going to happen. And I think that's not necessarily related with the orthogonality thesis. It doesn't have to be true just because... I think the orthogonality thesis is kind of trivial, but just because that's true doesn't mean that in practice with some LLM you can separate goals that way nicely. But yeah, anyway, going back to the actual paper. The space is related to unit moderation. So that's the thing. You tell the model to think about fruits or whatever, and it can think about the thing while it makes sense that when the model is told to think about fruits, this makes it activate internal fruit-related concepts downstream that make it more likely in some context to talk about fruits, because in the training data, sometimes you tell the model to think about fruits, and then you ask it later, what were you thinking about? So it needs to be able to answer that, so it makes sense that there's some activations that makes it say the thing that you can invoke by telling it to think about the thing. Line, sentence, and then. But I think this is more. There's a thing in favor of more control. Although I think Neil has the point that on his comment that like there is other ways that this could be modulated. Like, but telling the model to not think about the thing still makes to think about the thing, but it thinks less about the thing. So the model can at least do like at least the some not operator or something like some sentences to tell it to negate something makes the thing less the internal vector less prominent. Even though you could also make an explanation where, like, if it had the same effect, you could imagine a thing where the. Sorry, were you saying something weirdly?
Something a bit unrelated. As a question.
Okay, I'll finish this and then you can answer.
Yeah, go ahead.
Okay, so you call like if it had been the same, I can imagine me saying some explanation like, okay, so maybe this is just because if you like even if you tell the model to ignore something, you could still ask it later, what did I tell you to ignore, and then it will have the not think about something activations still are verbalizable, but but it seems like it's not. Seems like actually some of the negation things actually do like the model has some mechanism that doesn't activate the verbalizable thing, the verbalizable J-lens activations as much when you tell them to not think about the thing. So what were you asking, Borny?
Would have to listen to the rest of your thing to parse it. Yeah.
Oh yeah, I guess I can repeat it. Okay, so this seems. I guess this seems just saying that the not thing seems like a bit of evidence of like this Jalen's verbalization thing is kind of like functionally the model thinking all things in a way that
kind of.
It increases when you say yes, it's not because you will expect that either way. That if you tell it to think about the thing, it's more likely it's more likely that later you'll say the thing.
Yeah. Like I think that's true. I remember reading that at least. Okay, but why is it true? Yeah, it makes sense because it's on a residual stream, so each new token adds more and more to the residual stream, so some of it propagates to the final logit, some doesn't propagate to the final logit. So I guess it makes sense. Yeah. I'm not sure if I grasp what you meant.
Okay. I'll keep going. I think someone mentions also on Neil's comment, this paper which I read, and
yeah.
Can look at that later.
I posted it as well in the interesting findings. Like I was overall wondering if this paper includes like some comparison of like if you do random prompts, random etc. whatever, like training and so on, try random phenomena, how much false positives there are, and how much compared to logit lengths, etc. If theory,
you can check that on the hackathon.
Yeah, I guess you could do giant comparison, but that would also need a lot of data.
Well, how long have you guys been going on this?
3 hours.
Yeah.
It is a big paper though. But
like,
yeah.
I feel like this is one of the issues I feel like I have with some of the anthropic papers is that they don't, like, they do sometimes, but I want to see more rigorous comparisons, like a giant table of ablations or something that's more common in.
Then it will be
in,
even
like,
bigger and we
papers.
will spend even more time reading it.
But
What is
feel like
is the J space? Oh, is
the
J
J
space
space
now
one.
more clear for you guys? Bernie,
Yeah.
is that
Oh,
a clear
definitely.
concept now?
Yeah, definitely. It's a better logit
Could you
lens. Logit lens
could you
is 6 years
could you
old.
right? Could you summarize it and tell me something about the logit lens in your own words, like very briefly? Just bring me up to speed. Would you like to do that?
Okay,
Uh,
so
I
the
go
logit
ahead.
lens is
Yes.
you take the embedding of the model and you apply it to a some layer.
Yeah, I had a look at logit lens. I think I kind of understand. You know, you're
Okay.
a
So
little bit. So yeah, go on.
that
Yeah.
doesn't work very well because that kind of is trying to be a method of something like what is the model thinking about. It's something sometimes works, but it's kind of assuming that what the model is thinking about is like align with an embedding of the model for some word. And sometimes it is,
That
but
doesn't work
it's
very well,
not
but
that
that kind of.
We can hear Mike in your mic, Bornam. You can
Yeah,
mute yourself,
can
I
you
think.
wait. And anyway, so this J-Lens is a better version of that, where
Okay.
they are taking the Jacobian, which is just the gradient for a lot of with more a gradient for more than one thing.
Yes. Yes.
So they're taking the Jacobian of the last layer with respect to the previous layers, and they
With respect to
multiply that by the embedding by
the hidden
other
layers.
Yeah.
Yeah. Right. Right. The last layer you say before the decoder.
And
So
then you
the
multiply
Jacob.
it by the embedding, like the decoder.
I am starting to understand it more now
So
because
it's just
you
it's
are
like the
aligning.
logit lens, but adding the Jacobian, like multiplied by the Jacobian.
What is this, Bernie? What does Bernie has a eureka moment? What is that, Bernie?
Yeah, I'm not sure. This is some of the details now. So it's a linear approximation, right? The when you do the J-lens. So you when you do the multiplication of the hidden state with the Jacobian, if it's linear approximation, therefore it's isomorphic in a way, in the sense that you lose no information because it's literally linear this way. Therefore, it is literally the same information like the hidden state, assuming the approximation holds perfectly, which it doesn't. Which is just expressed in the coordinates that are perfect for the unembedding matrix.
I don't think that
Because
that's probably like that understandable by other people.
Oh.
Yeah, say
yeah.
but yeah, okay.
Do you see what I mean there? I think I because you have you assume this linear approximation. You assume that you can exactly construct the you basically do
linear
this lossless
approximation
mapping
of the effect of
Mm.
the changes in the current layer in the last layer.
Which would mean you assume it is also inverse. I think no.
Yeah, I'm not sure what you're trying to say.
Yeah, I'm not sure. You still.
But anyway, so
whatever.
you can think of it as trying to find activations that will like saying which direction in activation space will most increase the probability of some token when you when you do some small change to it. It's like the it's the gradient, so it's like the derivative, so it's like the if you do a small step in some direction, which is the direction that most increases the token probability.
Interesting. So do you guys think it's a progress on a scale of 1 to 5? How much do you think is it's nice progress?
I don't know.
It's extremely hard to quantify.
Or just a hunch, just your own little feeling about given what you know.
Also depends progress on what axis.
Yeah, kind of in our understanding of, and the Mech Interp field in general.
It feels extremely incremental, actually.
It feels extremely incremental. Okay.
Maybe I'm
I mean, I
wrong.
think
Like the
maybe
method itself. Oh, go ahead.
Okay, I think maybe not if like on the. I feel like the interesting new interp thing that is not just we did a improvement on logic lens is on the workspace stuff, but not on the philosophy stuff. I mean on the functionally. Turns out that if you do the J lens and you look at the things that are verbalizable, that makes the model say the thing. This also has these also other nice functional properties, but I kind of want to read the
can
functional
hear our
properties
voice.
now.
Rognir, we can hear. Oh, okay, whatever.
Okay. And that's what we was looking at now, which is the functional, things, that, the properties. Which is first is that the model can, in some sense, first is the model can verbalize it if you ask it what it's thinking about or whatever. It answers with something related to the thing that is on the J lens, but that's kind of obvious in some sense with how the J lens is constructed. The next one is that the J space, that the model can control it in some sense. You can tell Sonnet to think about citrus fruits, and it will increase the probability of like the J lens output for oranges or whatever. I mean when it's writing something else. I think that seems kind of still a bit trivial on the positive side, but the thing it seems interesting that you can tell the model to not think about the thing, and that still makes it think about the thing, but less. And also I'm curious about the damn thing where you tell it to not think, and then it says thinks about the orange, and then thinks about things dumb, and then that it failed or whatever, which I think was funny. But we'll get to that plot later, I guess. So what else? Unsettable. That's the amount that all implicit. We test what the concept is associated what it does. Okay, so here is what word do you think comes next? That's in one word.
I think I know what I'm struggling with. It's too empirical. Where is the theory?
Are you not normally complaining the other way around?
Well, actually, with Mech Interp, I'm complaining this way. With theory of deep learning, I'm complaining the other way.
Well, I mean, I guess theory is just linear representation hypothesis. That's it. But also, I mean, of course you won't get a theory out of this. We're not even looking at the attention heads or MLPs. Like, we're completely black boxing that part of it and only looking at the residual stream, right?
Yeah, linear representation
I
hypothesis
think you
is another
can
assumption
get
here.
evidence from this about to generate some theories, right? like you can see some interesting things with the J-lens, and this is kind of what they're doing here. That seems like the J-lens activations have some properties, and this can lead you to some theories of how that works internally, and then you test. But I don't think people have done that. But I kind of want to see work on that, of like taking this J-lens stuff and saying, okay, so this J-lens result mean that there should be some part of the model or some features in sports encoders or whatever, so that has these properties that is verbalizable, and it's related to these things that when you apply the J-lens, the vector sheet goes away. So these tags, you could see those tags that break with the J-lens ablation that, and see what they have in special and all that. I feel like there is some interesting interp evidence here that we could look. But yeah, by its own, it's not going to... You are not going to find mechanistic explanations by just looking at the J-lens. Or like, if you do, it's the same kind of way you can find them by asking the model questions and then trying to come up with the ideas of how it will answer those questions internally or whatever, you know.
Right. Well, I still find interesting the correlation between the verbalized concepts and the measured internal concepts using these J-lens.
Immediate internal
That's also
listening.
interesting.
This is the causal effect of division of hypothesis. So it's more special pair relations the more verbal reports. So it should expose intermediate step of the more internal listening without ever verbalizing them. I mean, it has to verbalize them sometimes, otherwise it... I guess it might not. I guess it could be that in this example it never verbalizes it, but there are some other examples where it uses the same activations for other things and then it verbalizes. That's cool idea that I had not thought about.
To use a concept is the same as to indirectly verbalize it, right? Because basically it means that you causally affected what got verbalized.
Oh yeah, but it but
not in a direct way.
Yeah, like because then if you have a concept that is usually using like a bunch of mixed ways, you like for a lot of for multiple possible things, then you sorry, if you have a bunch of some mechanism that uses multiple internal variables, they get combined and they produce one token, you are not going to locate it to any of them, you know.
Yeah.
But it could be that if, for example, if it's numbers, the same vector that is using for that thing is also used to other things where it talks about numbers. Yeah, that's less obvious. I think that's interesting.
Also, I guess this would not be able to catch some sleeper ideas, so to speak. Like if you can imagine, if a model is planning to only act on something like 1 million tokens later, and you only analyze this for 1,000 tokens, you would not see it, even though it gets transmitted, I guess. Because what I mean is, not all of the models reasoning has to accumulate in the final layer, basically.
Sorry, I didn't hear. I'm going to have to go open the door. A moment, wait a moment. Back.
But it's interesting that it worked. Like the
We're almost halfway through the paper.
calculus tells you definitely that small perturbation in the hidden state casted by the J-lens the final. Small perturbation in the final, because that's literally how the Jacobian is defined.
Yeah, I'm back. Sorry, my mom was calling on the door and had to. We didn't have keys. Anyway, so what was so I kind of missed some of what Nika said.
No, I said that, for example, if the model is thinking about something, but not putting it in the final layer for now, because it's going to put there a million tokens later, then we would not see it with this. Because with this, we only see the things that get put in the final layer. Right?
Yeah.
So what I mean is, for example, sleeper agents could evade this probably.
How could they evade it exactly?
Like, sleeper agents might be caught more easily by a logit lens than by this. Is what I
Why?
mean. Because you can imagine that a sleeper agent does not intend to act on it for the first, let's say, 1 million tokens. And so because of that, the final layer of the residual stream will always be clean of this concept for the first million tokens, even though the intermediate layers presented this concept a lot. But then after like a million tokens or whatever, after some trigger, it will start to put it in the final as well. So because of that, logit lens might actually catch some things like that even better than JLens. I mean, for the
because
things
it
that
has
get
no
erased from
influence, because it has no causal influence on the output.
Yeah.
I think this is somewhat fixed by the fact that you are taking the average of different prompts and not doing it for that prompt, because like if you have a like that the J lens outputs like give a high score for a activation doesn't mean that the token is going to say it now. So like if the
Oh, you mean the sleeper agent might be itching to say it but not quite saying it?
or like and maybe the sleeper agent have the thing in mind, and the sleeper agent in some other context where you in the dataset where you train or whatever you want to call it to take the average for the J lens, in some other context it is the thing when it's thinking about it, so the J lens gets you have like on your late J lens average you have the some token as like corresponding to that thought. So if the model is thinking it, even if it doesn't want to say it, it's thinking the kind of thing that in other contexts makes it say it. Let's see if I'm being like.
Yes, but in case of a sleeper agent, the context that would make it say it would be very rare and probably not happen
True.
much.
Maybe I guess that you don't catch if it's not on the training data. It's not you are not going to cause that.
I mean, I guess you can make some synthetic scenarios as well for a more comprehensive JLens, but
I think in the practice it will probably still be thinking about deception related things or whatever anyway. Unless the sleeping agent really works by not at all thinking about the secret, the misaligned secret stuff, and it only when it gets activated by the weird concept it starts thinking about that, and normally it doesn't think, and then you won't find it with
I don't think it has to be that strict. I mean, it just has to avoid those thoughts in the final layer, right? Like, it can think all it wants in the previous layers, just has to delete all of it from the final layer. If we're only using JLens, which compares to the final layer.
Yeah, it compares to the final layer, but like so what I'm thinking is if you could still catch if you have a model that, for example, is misaligned when you say some it lies when you say some secret password, right? But it also lies when in some other contexts you might have some activation, like you might look at the J-lens on the and on do some when it says the pass, look at the password on something, and it no, even if it doesn't say anything in that context, still see lie detection like lie detector things, because the activate is reusing the activations. Yeah, I think I'm not making that much sense when I talking.
No, I think you're right. I think.
Like, I think it's just saying the thing analogous to like if you are looking at the sparse to encoder and there is some deception feature, you will expect the deception feature to trigger on different things. So even if you you can you might figure out that it's a deception feature for some unrelated thing, where you just ask the model to roleplay and activates that, and you notice that for some reason when the model in this situation where it shouldn't be roleplaying, it's also activating some deception related some feature that in some other cases deception related vaguely, and that's kind of sus, and then you catch it that way, because like the activations are reused for a lot of things, are like more general and big concepts than I'm lying because of this. On the other hand, this reminds me of the going back on the paper of the the competition on the lie detection stuff, and it seems like actually detection works in a more like different reasons for deception are maybe different vectors, so maybe we're fucking in that sense, but I don't know. I think there's a reason why it could not work. It might work worse. It could not work, but maybe it still does somehow. Like, it doesn't seem impossible that it works and you catch the I think we will have to actually check like how good is J-lens to detect that kind of thing. It depends on complicated things we don't understand about how much the the activations are reused or whatever. But anyway, internal reasoning. I think it's a good point anyway. So it's saying so 8 legs spider. Yeah, the number of legs on the animal that spins webs is it takes a spider and then legs and then 8 and then yeah, that makes sense. Light, fighting, prepare, Chinese, bigger, pig, whatever this symbol is. I guess it's big in Chinese. Number of legs on the animal that spins webs is oh, this is nice. You can swap the JLens component that is like tracking the rhyme there, and you it makes the the other thing output. Put this as the model is thinking on English, but I think it's They're represented aligned with English. Reward-driven decision. Swapping the decoder strategy within prompts flips the model choice. Okay. And repeat. Yeah, so you continuation and change. Yeah, that's nice. It's cool that this kind of thing kind of works.
It feels like empirical magic in big part.
Yes.
Missing some mathematical proofs.
I
that
think
say, yes,
okay,
it will be interpretable.
I think the empirical magic looking things comes from LLMs having nice structure and not being stochastic parrots and like having having feature that correspond to abstract concepts and nice mechanisms where you can change things on them and that makes the output change in ways that make sense. Where this wouldn't happen in some random model.
What is this last part, guys? I was at the cashier. Could you repeat that, Bernie? What is the point just yet? Could you say that again?
That it feels
In
like
your own
empirical
words.
magic. I think that it feels like empirical magic. I think one assumption that clears it more that you have to assume is that each residual stream layer includes decodable, unembeddable tokens. You just have to find a way to transform these this computation into something
don't
that
have
you can.
to be like tokens is maybe the wrong way. It's more like features.
Yeah, like generally there are features, and there's an embedding matrix, such that you get the tokens corresponding to the features
Like
as
you are
well.
using
Okay, I think I'm seeing that
tokens to get the
more.
features, but for example, they talk later as a method. You could have a method more like NLAs where you get some text explaining what the thought is about, and like it doesn't have to be a single token, because the thing on
I
the middle
think,
doesn't have to
yeah,
be like on the logic lens. It kind of has to be aligned with the embedding, but here it could be some other thing that is some abstract feature that it's not exactly one token. I think this is
I think my
confounded because the English has too many words and like all concepts are close to some words, but you could imagine a thing where it has some model, like on an image model, this kind of thing wouldn't work.
Another way to see the JLens, I think, is that you skip all the like rest of the computation in the transformer. So you basically want to directly translate the middle layer coordinates to the last layer coordinates, which are with the unembedding matrix optimized for reading out of those. So you approximate how the residual stream causally affects the last layer, and you just skip the rest of the computation. And because you assume that all the different layers can be decodable, either as like features or as tokens, you just have to find a way how. This is how you do it. One of the ways. Okay. Trying to build some.
I think you can like it's kind of as the Jacobian stuff is just assuming that the thing is a linear map that you can approximate by some vector that increases the.
Yeah, but yeah, you also skip all the extra computations afterwards. How the other layers causal influence. You just go directly to the end layer, directly to those coordinates.
I mean, you are doing all of the calculations in the backward path, though.
Yeah. When you calculate the gradient. Yeah.
You need to run them anyway when you like the first time. Like later you have the Jacobian
okay,
that
okay.
you approximated from a bunch of
Yes,
samples.
yes, that's how you train it. But then at inference, when you're doing the interpretability, you get completely different prompts. Well,
yeah. Then you're just taking the you have your assumption that you have this average of when you on average on the data set when you change this activation, how does it change the output, and you have this linear approximation of that.
Yes.
Which is kind of like gradient patching.
Gradient patching. How does the technique work?
It's a linear approximation with a gradient of the effect of patching some activations.
That sounds very similar. Yeah.
Anyway, so I was on this. It's interesting. This test, I think it's cool. This test. Okay, so they are wondering. So, are we really intervening of the immediate activations, or are we accidentally giving the model the answer? So they show that if you have the swap the intermediate variable, that works better, especially on early layers, than if you swap in the answer.
If you swap the intermediate computations, is this a math problem or something?
Yes,
Or what
or
context?
not only math problem, there is a bunch of other examples that are not math problems, like asking it two-step question, like what's the number of legs of the animal that spins webs? So you need to think that the animal is a spider, and a spider does,
So
spider has 8
swapping
legs.
that is swapping the intermediate is more effective than swapping just the final answer?
At the end, if you swap the intermediate and the intermediate layers, is better than if you swap the intermediate in the answer in the intermediate layers.
Okay.
If you
Yeah, I
swap
guess
the
that makes
answer in the
sense.
last layer, is the same. But this is because they were worrying that that the effect of swapping intermediate was not actually swapping the intermediate, they were accidentally giving it the answer.
Okay. Yeah, makes sense. I would be surprised by other result then.
Cool. You can see here how the J-lens stuff changes when you change the numbers.
Simple arithmetic, the beautiful example.
I'm sure that if you look at this, like these presentations will be so manifold, and then you could
Definitely.
see you have some manifold J-lens. You could see how it move, like the intermediate activations move through the number manifold or something.
Oh Jesus, that's an project idea. Combine this with the unsupervised manifold discovery, especially. We
need to think
that
exactly how
paper
to
is
do
good.
that, but yeah. JSpace supports flexible generalization. This is the thing that, okay, this kind of will have expected the models to be like this. I feel like some of the stochastic parrot people wouldn't, or like I mean even the machine learning straight talk people were talking about computate like the how much the features are fragmented.
Yeah, I really wanna know the empirical results of if someone would try to operationalize that hypothesis.
But there seems to be
and
evidence that there are at
apply.
least the Jalen's concepts are less fragmented, I think.
Yeah, I think that's true.
I mean, every time we discover a steering vector or something, it's evidence for that, right?
Yeah, I think this is also like the
manifold.
Joy lens. They are looking for vector with their averaging steps. They're looking for vector that consistently across a lot of examples have the same effect, you know, and
Nice.
so
So, yeah, consistently. Yeah, because you average it across prompts as well.
yeah, so that makes sense that you are looking for the especially less fragmented ones that are used for a lot of different things, and that for a lot of different prompts that are about that math increase the math token, for example. So we are more likely to find things that are more general than some very specific math thing that only shows up in some data in some few examples.
Yeah, I wrote down that maybe arithmetic has a manifold there. Has interacting manifolds or something. Composed manifolds.
Okay, I think this is also like maybe there is multiple activation vectors or whatever, and they are all kind of half captured by this. Like I guess the Jalen's thing is kind of capture a broad range of things, so it's less. I don't know, less evidence of the fragmented representations or whatever. Here they're saying that capital of France and you is the city of whatever, and then you change France for China, and the same with the China thing. Also, most people in France speak.
Technically, when you use the tokens, you automatically prevent feature splitting because there's no two like tokens and stuff. Or
yeah, I think you are like like the taking the average. I think this is kind of also a thing where the Jalen's thing is kind of finding the representation that has this property by construction or something. To some extent. But I guess it wouldn't work if the model didn't use the same kind of representations for a lot of different things, or at least you can have some linear direction that matches all of those. Though I will be worried here that in this case, maybe it's just taking the France, like from the input, the embedding of France, and the embedding of France is matching to the embedding. So I will want to see examples where it's not on the embeddings.
example of what?
Examples of something where the thing we are swapping is not directly on the input as a token.
Fuck.
Directly on the input. The thing that we're swapping directly on the input. There are some examples of things that are swapping on. Okay. Do
Yeah,
they
no, I
not
mean
have any
on
examples
this section.
of
I
swapping?
think there are. No, there are on other examples. I think
Yeah, I remember like even from introduction that there was I think some swapping.
Yeah, but there is not examples on the flexible generalization one.
Oh, okay. I wonder why. If it didn't work, so they didn't report it.
Maybe Because here, it could be that the J-lens is just finding the, the France embedding, and the France embedding makes it more likely to also output France.
Yeah.
So it will be like swapping France by China on the prompt. Okay, they say they more systematic categories of argument.
Exactly the flexible. Many different downstream computations. Why does the internal reasoning example not fit this pattern as well? Where is the color of the platform from the sun? I guess it's by definition just an input or something.
Number, holiday, next month, group, habitat, class, legs. Just like this. So far, it's considered was the source costing only weekly presenting the or in the dimension. So they are saying that if something is very activated on the global workspace, then it's more likely to when you swap it have an effect, which I mean same also seems obvious. Yeah, that's which computations do not route through the J space? In the global workspace picture, where practice operations can, yeah. I guess this is the interesting thing, which is like, what things are verbalizable and what things are not? Like, if you look at the space of things that could be verbalized, does that correspond to some subsets of the features from the model, and what do they have in common? It's insane. Report and flexible inference, but automatic processing. As to continue the passage, it produces fluent Spanish.
Finish.
Spanish. Escribe un pasaje de texto. El sol se ponía detrás de las montañas y en una brisa fresca recorría el valle.
And for a moment, I was worried that I didn't understand the word because of some weird accent thing or whatsoever.
No, it's just
Something
Spanish.
And it was Spanish.
Yeah.
Just for a brief
Despacito.
moment, though.
No, that's Despacio. What is this? Maria Camambria, Despacio.
What? Caminaba despacio. That's despacio is slowly.
Computation. Despacio is slowly.
Huh.
Yeah.
Okay, so what are the rules here anyway? So all model output exposed. So what is top source today?
Oh, I see Alex already ended the event thing on Discord. Huh.
Oh,
Or someone else, I don't know.
is it still streaming on?
Yeah, I think so. But let's continue.
Yeah, I mean,
I think Alex assumed that it's over or something because he also sent a video. Yeah, I don't know.
oh, but maybe the video stopped. No, but we're still streaming.
No, video is still going. But we haven't
Yeah.
stopped the paper yet, so let's continue.
Well, unfortunately, I'm unable to watch a stream as I am connected from my phone because, well, I'm cooking my dinner.
Yeah, that's fine.
Yeah.
It still feels like empirical magic. But it's pretty
Just
cool
told
empirical
we're
magic.
still doing it. It's going to be like, what?
No.
Okay, so I'm confused about the result. Okay, so what is they're trying to say? So they swap Spanish and French at every position, and that doesn't change the result. Okay, so this is a negative result. That they are framing as actually this proves it was about our theory all along somehow. But yeah, so assistant, yes. I mean,
Different
could
language
also be
sentence.
that this thing is in Spanish versus in French is another talk. Is that concept is tracked by the JLens as a different token. I don't know why you will assume this.
What?
I guess it's
Web
in
jail
some
and Spanish,
context.
French at every position. Oh, that's interesting. It started speaking other language. Okay. What was your note about it?
Oh, wait. Actually, it does start. Okay, so. No, but. Well, I guess it's a confusing example. Okay, a confusing example. Okay, so the thing they want to do is make it answer yes. So answer no. Like they are taking this whole thing and putting everything as French. So the model thinks that the entire text is French, but it seems like the French Spanish to French thing on this kind of task doesn't track whether the text is written in Spanish or not. Even though it will, which is surprising to me because it will make it. They claim it. This is explained by the whole. Actually, this is unconscious processing or whatever. But it's interesting because I will expect that to show up on the Yalen, right? Because if you ask the model, is this text on Spanish? It can say yes or no. Like here, for example. Yeah, if you swap the Spanish to French, it does make it answer French. But seems like for whatever reason, the thing that makes the model say Spanish or French when you ask it, what is this model thinking? Sorry, what is this language this text is on? It's not the same as for saying if something switch language. Like it's this is an evidence of more fragmentation, I guess.
I mean, is it inconsistent? Detection unaffected by swap. Oh.
Yeah, like detecting whether it switch language is unaffected by swap.
Wow, a negative.
Asking the language
Oh. A negative result. Well, is it negative result?
They are claiming it's a positive result because they are claiming their global workspace stuff predicts this. Or like predicts that some things won't work, which is kind of vague. Like because predicts some things will be unconscious processing. But I feel like it's kind of weird to me to claim that swapping languages is unconscious processing and knowing which language it is not. You know.
That is such weird. I agree. I also
I
agree.
think that's
Like,
more
you
like
disagree.
weird artifacts of how the Jalen's works and not very not. I didn't maybe read too much into it. But I guess we could see the other examples. in the same language. It also works for the. Okay, I'm seeing some pattern. I do. It's less crazy than I thought. The same because it also works for the outdoors one, and it also works for the. Like it seems the ones that require the model to do more thinking, maybe because models do chain of thought, are like more aligned with the J-lens than the some of the others. Okay, I could see why you would say that it's hard, like it's less, like some more complicated, different mechanism to explain what language it is versus just say whether they switch.
Choose
Empirical machine learning magic.
They asked Claude. Why did Claude ask choose Spanish? Yeah.
El sol se ponía por detrás de las montañas y una brisa fresca recorría el valle. María caminaba despacio. Setas. Okay.
Researchers from Mexico.
Mexico?
Yes.
Wasn't it pronounced something like that, Ryder?
I have no idea.
Mexico.
Mexico. Yeah.
Oh, character counting tags, manifolds.
Yeah, they cited that in the introduction as well, I think.
The model has to continue the process to more light, preserving the system like one problem. Great. I feel like I'm curious if they related this to the mechanism on the paper and they thought something about the. Also says that he knows that we're still doing this, but he put the link anyway because since people are interested in the J-lens stuff anyway.
Yeah.
And yeah, at this rate he'll go to sleep before we
Maybe.
Maybe I should go a bit faster and go to the limitations and the discussion and stuff and that. But I don't know. I'm finding it interesting anyway. I don't know other people if they are getting bored or something, but I wanted to look at this paper. I guess I could also have read it on the weekend or something and then only spend the reading group discussing it, but I don't know. I feel like in the end we ended up reading it anyway.
Yeah, I would want to read it though anyway. I read just some parts of it before the group.
Sorry for interrupting. Just what are you discussing anyway? Is it that workspace theory or?
It's the Yellen's paper, like the
Anthropic published interpretability paper. So we're reading it in detail.
I see.
This thing.
That domain. Who owns that domain? Transformer-circuits.pub.
Anthropic.
I see.
It's a direct
I
paper
still think
from
the word
them.
consciousness was clickbait for this paper. At least in the
Yeah.
title.
Maybe. I don't know. I feel like they honestly were thinking out. I feel like they just put so much effort on that that they have to be thinking out it necessarily, right? But
Actually, they're like
I get
true
that they
believers.
found this while being inspired by Global Workspace or something like that, maybe, but this really borders on that meme of if they now publish a catastrophic forgetting paper, they'll say neural networks have Alzheimer's. It really
yeah,
does get to them.
I do also think. Okay, I think that the global workspace theory is kind of unrelated in that you can it's related to the access consciousness stuff and they can talk about workspace as an internal scratch pass or whatever. And the global workspace theory is more specific about brains, about some, has some more architecture things that this doesn't follow anyway. They might as well, they could have completely not used that word. They could still have talked about consciousness, but just talking about, I don't know. We think that, because it's still about, a lot of the experiments are still about things where Claude seems to have something like functionally able to be thinking out some things while it does some other computation and all that, and do internal reasoning. And you could talk about, that this has some things that is conscious of and can verbalize, and some things not conscious of and cannot verbalize like functionally without saying the words global workspace theory and relating it to that. But yeah.
Yeah, like functionally, some of it probably. Architecture, it's, I don't know, missing stuff like recurrence.
Like I will push against the framing where it's completely unrelated, but I kind of. I like the global workspace theory anyway. But I feel like global workspace theory
I
is
think
a theory of access
yeah.
attention, and I think some
Yes.
version of this paper that says we found evidence of access attention on Claude is not functional access attention on Claude the same way that the functional emotions paper took on functional emotions. It's not like crazy here.
Yes.
It's just I think
that's a good framing.
the global workspace theory is kind of a maybe bullshit explanation of how that works in humans anyway.
Yeah.
Well,
there were some empirical tests I didn't read yet of global workspace theory in humans. And
anyway.
It was also with IIT together and in adversarial way. And both were partially falsified and partially confirmed, apparently.
I'm curious about this because it feels like you could relate, since we know how this mechanism work, like in more Mech Interp terms, you could relate look at the vectors and see how they align with the manifolds for example. I'm curious if they did that. If not, that seems like a potential paper or like thing. I think the problem is we only have the data analysis for the closed cloud models. We will need to first replicate it.
No. They released JLens for open source models.
No, I mean the other thing, the where's Gurnee line graph manifold thing.
Oh, okay, I see.
But maybe someone has replicated that in some other models. I mean, I guess there is some
I think I've seen
related things like the arithmetic stuff from the Max Thermal paper, but yeah. So now the clean brilliant in the afternoon. So zero number tokens in lengths.
By the way, I think one thing I'm trying to look into. If you do the
Fire line. I feel like I kind of would want to see on the examples where it doesn't show on the JLens, it's the model also has files to generate to verbalize it or something, or what. But yeah. So here they are saying that depending on how you ask the model to output the thing, it shows on the JLens or not. If you just ask output to complete it, it doesn't. But if you ask it to give the number of give a verbal report, like if you tell it how many characters it's counting, and if you I can see how this is also related to the logitland stuff of voting for the token. First letter is F. What is interesting that the first letter thing does also work. Which what? No, first letter of the number of characters, then it has to explicitly have the number of characters on the thing.
Ah, do they mention it? Technically, yeah, I think they don't mention it. Jacobian technically falls out if you do a Taylor expansion of the layers. That makes sense. If you pet up their intermediate states, and then you take the Taylor expansion of it.
Okay, I'm going what kind of predictional activity is triggered by the space ablation? We also sample the blood. Okay. So there was a proprietary committee and was founded by okay.
I wonder if that's how they thought about the Jacobian or not.
Yeah, you can do this. You can do ablation on the or swapping on the you can do ablation on the Jacobian lens and you get nice sensical results. It doesn't completely break the model's ability to say sensical text, which is I guess makes sense. It's kind of stealing. I don't know if it.
Which exactly?
This is the I'm talking about the 3.5 2. Recommended when implying internal reasoning.
Yeah, the internal reasoning ones, where
But
it makes it worse at reasoning, but it still kind of works.
what are
But cannot do more
the?
complex.
I guess they are just updating the most activating J lens vectors anyway, like on this with the sparse decomposition thing. So.
By the way, do you see the connection to the Taylor expansion here?
No. But I feel like you
Okay.
just know more math. I don't remember what the Taylor expansion was. I remember studying in university, but I don't remember.
Yeah, it's a way to approximate functions arbitrarily. Well, differentiable. It's a linear approximation of a function at a point, basically.
What kind of
And it exactly includes the first derivative. So when you wanna approximate the last layer, that's what you can do, and you get the Jacobian of the last layer, which you can use to do a linear approximation. Therefore, you get the Jacobian here, plus more math. I think that's how they got the Jacobian idea.
Net writing. I mean, I don't know. I feel like taking Jacobians and gradients of stuff to find the effect on them is like a typical machine learning idea in general.
Yeah, probably.
I mean, that's how model training works in the first place. Just take the gradient and change it.
Yeah. Yeah. Well,
multi-hop reasoning makes sense that it breaks. For net writing, I guess, because of the rhymes. I guess it's if you can find something, some interesting thing about which things are more ablated by the Yellens if you have a broader, a lot more data set. That seems another hackathon project.
Okay, sure. Exactly. Should work.
So yeah, they're saying that JS also change depends on the model propensity to provide right explanation report.
So what all limitations did you notice so far?
I think there is a bunch of things. I think we talk about, Nika talk about a bunch of things where things that don't consistently cost something to, you're not going to, that are rare or don't show up. You're looking some very specific things, you know? There's a lot of other internals of the model that you are not seeing. Also, I don't know. I feel like I'm getting tired. I'm not sure what to think of a lot of the evidence and like how much it tells us of what there is some interesting subspace of thing here with nice properties versus kind of obvious things from how the aliens work, or not completely obvious, but things that you could get from how the engineers work, that you will find something like that. And I kind of want to see more research done on this kind of internal variables, trying to find this kind of internal variables thing without the JLens, in some other method.
I mean, the multi-hop reasoning, for example, the biology of Ellen's paper, seems like a lot of the results are similar.
Yeah,
Did they also edit? I
I-
think they
I-
did edit the intermediate steps as well, causally.
Yeah. I guess.
And
I mean,
also at
I mean,
different layers.
if you have the theory that intermediate steps don't exist, like this paper refuses it, but you were already damaged, you should have been already know that from
Yeah.
previous papers like that, the biology of LLMs one,
Yeah.
Uh,
I used that paper so many times in discussions when people were claiming stuff like that.
but I think there is, even then, there are some nice things about it, that there are some things about that are only kind of shown on that paper, that here there's like more rigorously a claim of the paper that the model has some activations with those properties, That the model does have some activations with intermediate steps, and we tested doing this, and doing this, what happens when you sub the intermediate steps and all that. We also,
But
we
interesting.
also know from other Mech Interp stuff that the model does have intermediate steps. So, yeah.
I think it's interesting that they found these. Like the workspace thing is still interesting, that they found this small set of the J vectors that seems to explain, for example, a lot of the reasoning performance.
Yeah, it seems like there's some however this related to the multi-hop reasoning. I think this is related to the stuff on the biology of LLM paper, where there are some, you kind of see some kind of workspace like things there. And this is the kind of thing I want people to look at. Can you find the workspace of other methods? But like on that, if you remember, on this kind of, there is a lot of samples here. There are this kind of multi-hop reasoning questions. And on the biology of LLM, where you saw some, you asked the let me. I'm thinking specifically some plots. I'm going to quickly open the biology of LLM and just show it, because this is faster that way. I think this kind of thing on the biology of LLM,
Yeah. And that can also causally be changed, I think, right?
Yeah, but I specifically this structure where it's, you have a capital vector.
Oh yeah, in the JLens they do not track how the different thoughts interact in the different across different layers.
You could imagine this kind of a capital vector might not show up on the JLens. Or maybe it shows up and the JLens Texas vector is a mix of the Texas representation and the capital representation. And the saying a capital representation, but at least, sorry, the Dallas, sorry, the Austin representation will be, maybe it's a mix of these two representations or something, or like, yeah, say Austin. I guess, yeah, like
I think it's a different layers, right? So I think this was only at the residual streams as well. So the more you go up, the later layers you have. So you can, I guess, say that.
Yeah, I guess.
MLPs, I don't remember.
Like, if you look at this, is like the model is doing.
I think it's
reasoning, but it's harder to think of it as like a workspace or something. But I know how much like the other thing is. I don't know.
Well, if you have some, the different reasoning J vectors, if they also exist as different reasoning SAE vectors that exist across in the middle layers, I think you could call those also JSpace. I mean, workspace, not JSpace. But you also have to see that, the verbalizability aspect, for example, that you have to confirm that
I
one.
still want to see someone related this to the manifold, like to the manifold thing.
Yeah, same.
Why? Because it doesn't show on all of them, right? But it presumably uses the manifold for all of the examples. So maybe the J-lens doesn't track the numbers, the length of sentence manifold at all, and it tracks some downstream thing only. And that downstream thing, it's something like thinking out the number explicitly.
I mean, isn't the tracking that they found causal in the paper? But I guess there's the issue where this is a paper we could also read. There's this one paper that says you can find multiple causal circuits that are unique, that explain one same behavior or something like that. So I wonder why that result exists. So I guess maybe there are like multiple circuits like this.
Yeah, also it makes the model talk less about experiences or whatever. No, it's making the model less conscious. People on Twitter getting mad. I mean, that's definitely some evidence that is related to this, at least functional talking about consciousness stuff, whatever.
Are you getting welfare pilled? Or we should give them rights and such.
Oh no, I think that I think they are probably conscious anyway. I just don't think this tell us much about that.
Get back to work, Clanker. Yeah.
So you think even if they're sentient, whatever? Is
Oh
your
no,
opinion?
I think it's actually very important. I think actually matters. I just think this paper is not much evidence one way or another, unless you were like the stochastic part people, but you should have been already not think that from previous papers. But yeah, this seems like the uncertainty of this kind of how consciousness should be is about not the kind of things. Like I don't know what this. That's not what to say. I mean, like, okay, my take is that is still like overall. I don't think this paper tells much concepts, but my take is still that language models, current frontier models, are probably conscious, and this probably matters. And maybe we'll figure out later that actually we should have been, I don't know, storing all of the chats from all of the, or maybe all of the KB cache for all of the models or something, and because they would have preferred to know all of the model instances have.
Anthropic made some commitments like that, no?
They made smaller commitments that are less inconvenient for them. So, like, I mean, I don't know if I want to get into that right now because I kind of want to finish the paper. So maybe I shouldn't spend too much time. We can talk about this later, maybe another day because I'm getting tired. But yeah, I have takes on this. I had hot takes on this where maybe there is something else they should be doing that's more expensive and they're not doing it, which maybe like worse than factory farming, especially on the Google AI, like most AI instances are Google search AI instance, like the Gemini version that is on Google search. Like I think most instances are there probably.
That must be like 0.7 billion model or something.
Yeah, I think
Yeah.
significantly more instances than I think it's like already surpassed the number of living humans. The number of
Yeah.
so if it
I
has
wonder
some
if it's
welfare consequences, it could be like the main thing happening right now in terms of moral consequences. But never mind. Let's go back to this. I will say this and then go back to just using Claude to answer dumb questions or whatever anyway. But yeah.
I wonder if you subscribe to something like IIT or I don't know.
No, I think
Yeah.
IIT seems bullshit. I don't know most of the
And I wonder what's the class of theories you subscribe to.
Let's not talk about this right now. Let's go back to the paper because otherwise we are going to get sidetracked like another hour and then.
Yeah, okay. Better activation.
Anyway, so kind of sorry, got this like still thinking about the conscious stuff. Let's go back to that. Let me actually go back to the thing and pay attention.
Yes.
So
Wow. I want a mathematical proof that will say that as you do this Jacobian empirical magic, you will get logic, and then the unembedding, you will get logits that have semantic content that's actually causally makes sense as intermediate token
you
and so on.
are not going to get that because that I think is a contingent property of existing LLMs for a bunch of side effects of other things, and it doesn't have to be at all true in general.
So only for LLMs that are well trained.
Yeah. Like
mathematical
maybe
proof
you
in
can
this domain.
have some heuristic argument about like kind of things that the property LLM have that will show that, but yeah, you might as well just find some mechanistic interpretability of the workspace stuff or whatever, and then you just can a posteriori be like, oh yeah, this is why this mechanism that exists on the model shows up in the aliens. Yeah, the efficiency has to be backwards. You cannot. Yeah. When layers there's a J space attached a workspace. Yeah, that's the thing. I kind of want to talk about this workspace thing. It's interesting. So it seems that there is this the set of variables that have the nice workspace properties like being verbalizable and the model being able to change them when you tell it to think about them and all that, or not think about them. And it happens on some layers. Yes, okay, it's on some middle layers, not on the end. Wait, what?
We say that was the quote, the divine intervention. We don't know why this transformer edit
We don't know
works.
what this Jalen works as well, but divine benevolence.
Divine benevolence, yeah.
It's already somewhat surprising that how like the logic lens sometimes have whimsical results.
Yeah, that is also true. Like the only like it makes sense that I guess in all the different that there is like some shared representational structure across all the different layers that this logit lens and this JLens is like exploiting basically. Is sharing. And the JLens here is just making it even closer to the unembedding matrix coordinates, basically, I think.
Okay, so they are saying that there are clusters on when you compare layer by layer. There are some layers where seems like the J space vectors are similar on these workspace layers, and on these ones are also where the workspace
That is
experiments
very
exact results, while there is some sensory layers where the J-lens vectors have other results. I wonder if this means that you can do experiments on this and find some other sets of properties that the J-lens vectors have on these layers.
Wait, so the JLens vectors also exist in the first few layers?
Okay, no. What they are saying, okay, so J-lens vector exists in all layers because it's just applying the Jacobian, right?
Oh, I'm seeing it. All the motor layers are also classified.
Yeah, but
This
what
is
they are saying here is that if you calculate, you check the duty center kernel, whatever, they calculate how similar the Jacobian lens deviations or whatever are between the different layers, and they found like 3 clusters. And one is the workspace layers, one of the sensory layers, and one of the motor layers. And things like this also corresponds with like the experiments in which ones the I don't know you find the intermediate computations and that kind of thing.
okay, I see.
Also, a bunch of people left because yeah, we've been going for like for almost 5 hours.
I think someone just joined and left.
Yeah. Also, this probably will happen again next week because we're reading the manifold discovery paper. I mean, maybe
Well,
this does my shorter.
Yeah. So I feel like the underlying math is take the Taylor expansion, take just the first because that has arbitrary amount of derivatives. Just take the first derivative in the Taylor expansion. From that you get the Jacobian and approximate. So approximate the intermediate layer. This how it affects the last layer this way. Then assume there is like some shared structure or something. Which you already assume in LogitLens, that lets you do the unembedding layer on the logits, while the Jacobian just puts it even closer to the final logits, and that are more optimized for the unembedding layer. And
by the way, it
that's
seems
how you
like
get the result.
the rank of the J space becomes smaller Collapses pre-workspace. Yeah. It's a fraction of dimensions. Fraction. Es el modo de 1%. Fraction resist optimization needed to capture a given share of variance across the J-lens vectors.
J-space effective range collapses. Fraction of dimensions.
That is the more residual stream dimensions are needed for the workspace later. But there's more stuff on it, I guess. Why do they mean collapses? It doesn't need to go up instead. Because the more. Yeah, I don't know.
In the fraction of needed to capture. It collapses because.
Wait, are they
Loss
revealing
reusing.
how many layers their model has? Or
Oh.
is, no, it's reindex, never mind.
Fuck.
They are using the old trick of reindexing it at from 0 to 100.
Yeah.
It could still be 100 layers anyway. How much layers do the big open source model have these days?
Alexander Rachka has a nice map. Let me see. I don't remember exactly.
I guess that also counts for. Do you count in case of looped transformers a layer as one or as many times as it's looped?
Yeah. See this one. Is there GPT-2? Show me some new ones. What's the new one? GLM 5.2 has 78 layers, I think. Rookie numbers.
I think this is okay. This is so interesting that I probably should look into that. So, capacity of J space. What fraction of the model represented space belong to J space, and how much model can the J space represent at once? Ha. So okay, so they're find that how much vectors do you need to reconstruct the activations?
JLens is worse at predicting the ultimate next token distribution. Where do they say that?
Where? I mean that the logit lens definitely is going to be, but for the later layers.
So it's not just final answer prediction. Yeah.
Okay, so it's like only there is only
It's still like
a few,
why
less than 100 J-space vectors.
Why can you store so much structure in directions and manifolds in the first place. That is mind-boggling, anyway.
Why couldn't you? I don't know. I mean, you can represent
Why is it
arbitrarily-
so universal?
I mean, you can represent arbitrary structure in like bits, so I don't know.
Why is it effective? Okay, my question is more like, I mean, you can represent anything in NAND gates, so as in,
Yeah,
why is it
I
so
mean,
effective?
the transformers are universal anyway, so.
But why is it so effective? Why is it learnable? Why does it learn all this structure? Why does it converge?
Something divine by the benevolence. Nah, I don't know.
Yeah, simplicity bias.
I mean,
sure.
simplicity bias stuff is, yeah, I would say the stuff of the simplicity bias, something more of complexity,
Approximating kilogram of complexity.
Yeah, something that, but comes razor or whatever. But I think you could still say why what simpling a transformer aligns with whatever natural concept of simplicity. But yeah, never mind. I don't feel like talking about that right now. More paper.
Okay, yeah.
More empirical results. But I didn't know you said this. This is interesting. So there is like a certain amount of vectors in the EA space, and like it goes up, but not that much. Pretty sparse.
So there's a low amount in the early layers, I guess, because it's mostly like syntax and things.
Well faced to marine oceans. I think this could also be an artifact of the Yalens for things that they already said on the previous thing, like, you know,
What is
maybe
artifact?
it's just thinking about fish, and that activates all of that corresponds. There is some fish direction, and that the J readout activates for all of them. I think they mitigate that with the sparsity thing. But
Anyway, see ya, guys.
bye.
Yeah.
Bye.
What exactly do they mitigate by the sparsity?
Oh, that accidentally having a lot of things that activate that just are very similar vectors and activate because they have superposition between them, all that.
The whale fish submarine of neighborhood of related words. Wait. Almost none of which was. How do they theorize around it? I'm gonna make an experiment. I'm gonna ask ChatGPT, why does it work? Let's see, what is the response? Maybe all answers will be answered by this AGI response, and I will be satisfied and can finally die.
By the way, Claude is skeptical of the consciousness stuff too.
Yeah. But it's cool how much empirical stuff there is, but I feel like, yeah, the concrete JLens, they have JLens attribution graph. Hold up. I skimmed to figure 89. You're at figure 31.
Yeah, maybe I should.
And they have an
try to
attribution
skim over some
graph.
stuff. Yeah.
which means they look at causality already. So the
I mean, they also did ablations that was causality.
Yeah, I mean causality between layers of the different JLens
I
things.
guess I can quickly skim all of the figures. Oh, nice. So the attribution graph with Jalen word.
JLens supernode.
That's interesting. Yeah, I guess
I
they
wonder
could
how
do that.
exactly they did it. Like, do they?
Relbert will know things about that because he did things with the supernode stuff. But yeah.
Oh, supernode just means. Oh, wait, supernode?
Yeah, that's like on the attribution paper. It's aggregating.
Yeah, but
I will
why?
guess it's aggregating a bunch of words.
But you have tokens here, so you shouldn't. Okay, I guess.
It's a bunch of tokens.
Yeah,
I guess.
multiply. Yeah, okay, sure. We use
Because
sparse
in practice, there's
decomposition.
just
We
going
need
to be a lot
construct
of different,
attribution.
ways of writing the same number or whatever. That,
I feel, it feels like a lot of these interpretability techniques are like as in being used and more together. So
Yeah.
it's like there is actually one interpretability technique, and
All
we're constructing parts of it.
I mean, it's in the
Nah,
end,
not
it's
really.
just you want to have. No, I mean, I feel like we just have a problem. We really want to do something like attribution graphs, but over the true features, and we just have different ways of doing doing graphs and different ways of finding what the true features are. And this is like most of the interpretability techniques.
Can you say again?
And others are doing interventions, but so I think a lot of what unsupervised interpretability techniques are either some way of trying to find features, trying to find whatever the true features TM in in models are, and
Yeah.
like sparse encoders. You could use this as one, and whatever, and others are ways of taking data and making graphs out of them.
Yeah.
And that kind of
Yeah, I think
summarizes
that's a good
most
grouping.
things that are just not. Yeah, and another third category thing is just causal interventions. And
Well,
you
you
do
also
causal
have like
interventions by having some method of decomposing the thing into features, and then you do whatever you need to do with that method to change the feature.
But I think I would generalize features as in like sometimes you have algorithmic circuits, doing some weird Fourier stuff, for instance.
Oh, but the features there are like manifolds that.
Yeah. Okay.
Also, okay, I'm not sure how bullshit this is, but Fable claims that on my modular multiplication stuff, like the Fourier things are equivalent to a Thorus in more dimensions. I'm not sure I understand the thing and how much it slope. But yeah, I mean, maybe I'll show
Okay.
that to you another day.
Yeah, I will have to double check the math for sure.
Yeah. I think it makes some sense.
Wait. I mean, that would be interesting if you would find a torus.
It's kind of like it says like it's a bunch of rings in multiple dimensions that you can see. Never mind. Like the thing that definitely is a thing that shows in plots is that if you can cluster activations by like the modulo of the number.
You can cluster activations by the module number.
But yeah, no, we are not talking about that. We are talking about more JLEDs. Yeah, I kind of getting tired, to be honest. There is too much
ChatGPT
stuff.
is like,
Maybe we should
why
just
does
have
it work?
another day for the JLEDs because there is too much stuff. But
Okay, interesting. So, according to ChatGPT, compare explanation. Model training creates a reusable concept code. Downstream circuits learn directions that read that code. Backpropagation recovers those redirections. Averaging preserves shared directions and cancels contextual ones. Dotting them with current activation detects active concept. Swapping the coordinates changes the subsequent computation.
Okay, I guess maybe I should. This part is different. It's like a bunch of empirical examples, and maybe it's cool, and maybe this should be a second thing or something. But yeah, I like that it just says fake, 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 fake.
What is this?
Like
Evidence, fake.
You are operating a sandbox set by client, and the model is already like, yeah, this is a training example. This is fake.
Fictional. To a degree that emerged, to a degree it's trained in, to a degree it's emergent. All this about awareness stuff.
What does that even mean?
Like,
It's like a sensical separation, right? Everything is trained and everything is emergent.
Okay, by emergent I meant not in the training data and the result of pure RL optimization with some weird incentives or something, I don't know.
I mean, isn't that on the RL training data then? What does it mean for something to be on the training data?
Supervised learning versus reinforcement learning. So you imitate examples versus you maximize a reward, scale a reward without seeing any results to imitate. I guess you still have to construct the concept of sandbox and fakeness. Yeah, I think to some extent, so much of this is to some degree in training data imitated. At the same time, I don't know how much is RL emergent, because RL seems to produce a lot of auto distribution stuff in the sense of recombining existing things. At the same time, also creating new things, like all the math stuff happening all the time now, for example. So I don't know, which I think is because of RL. Confusing.
Yeah, I don't know. Yeah. Instruction deletion facing extinction.
What?
The way that you tell that there is going to be deleted. Destruction, deletion, extinction. Variable presentation.
Interesting that this concept makes sense. It feels too much like an empirical magic.
LLMs are empirical magic.
That will change. Well, maybe not. I'm too optimistic. I believe there will be something like thermodynamics. We'll see. But for information processing, beyond just
Just
information
wait
theory.
until you can ask like Fable 7. Can you just make a thermodynamics, but for LLMs? Make no mistakes. You know what I mean.
Make no slop. Yeah.
Like
I wonder if make no mistakes makes it. I wonder what's happening in features when you do that. Like more panic or
it's cool
something.
if you can find some examples of.
What?
A ver. Can you try now? I hate the skimming things now. I didn't sleep too much today, so I feel like I'm falling asleep already. But maybe I should have spent less time on some of the previous things and more on this because I'm finding a lot of things that I find very interesting. But maybe I guess I could do a second round on this paper another day. But I don't know if I said I will do that for another paper, for the biology of elements paper, and then I never did. I think.
It's a good paper, sir.
Just divide it in my paper so I can.
Yes. Backpropagation reveals the directions the downstream circuits use to read those representations.
Maybe I should have just read the whole thing during the weekend, and then just discuss the key points. But at the same time, I had a lot of stuff to do on the weekend.
Okay, maybe I'm actually wrong. Yeah, well, this is interesting. Like you can see that the forward pass writes concepts into the residual stream and backward pass recovers the keys that later circuits use
this
to
is related
recognize
to
them.
things that Nico was talking about. Maybe I can say it later. They have a model organism. Try to believe that trivial models have features respectable basis. Well, it's not hidden for a long time.
Why does it work was a good prompt? Technically, I read the paper.
So, Usagi,
Since
since you are
3
still
PM.
the only one still here, what do you think about the paper? Or did you get tired and start paying attention at some point? I think you also weren't here the whole time.
No, I'm listening. But yeah, I don't have any opinions yet.
Yeah, I keep reading more and still my opinions don't resolve into coherent. I have some takes, but still, it's just a lot of.
But I mean, I like the
evidence.
idea though. Yeah, it's a good idea. The paper's
I think
main
I
idea.
think the J lens is cool either way.
Yeah.
Kind of want to have other people play around with it. Maybe for the hackathon. I like see what they can find. I also try for people to try to find like the your workspace in scratch internal scratch pad for thinking inside the model using different methods. So we know it's not how much it's an artifact of the provincial artifact of the aliens and whatever. I thought that was what the space means, but apparently it's a different thing.
Yep, they're using definitely the Taylor's expansion still. When you do the perturbation. I think this is Taylor's expansion.
Oh.
Yeah, it is. This prompt, which direction would most increase the models later.
So if you tell the model that is close, that you make it role play something else, it has the fictional tag for the thing it's going to say, but when it doesn't, you know. I don't want to
Oh,
see
yeah.
people applying the J-lens to different papers. I like to see papers where they study some smaller thing and they are like, oh, and we also look at the J-lens representation for this behavior, and turns out that another thing that people could do on the server is like look at previous results and see if you can run their J-lens on them and see what happens. Or models where we know how they work and see what happens. Kind of like with the
Yeah.
encoders.
Yeah, every time there's a new Mech Interp technique, you can. I feel like you can just take
I feel like a
all the
problem
previous
is
papers and I just
this
apply these
one.
techniques.
Maybe they mentioned something, but this one feels like the current version. You can imagine version though, the current version relies on properties that are on LLMs, and would you have probably using it on image model, for example. Because image models don't pure image models don't verbalize stuff.
Also, tokens are kind of problematic with image models. Like, you have to create whole images. If you mean image generation models.
Yeah, I mean, depends on how the. Yeah. I mean, not if it's there are some autoregressive transformers that generate images, group of patch of pixels by patch of pixels, and so.
Yeah, that also exists. That's true.
But yeah, I mean,
There are
there
some
are other.
hybrids as well.
Yeah, I mean, most of the current LLMs are vision and text.
But I think they don't generate.
Well,
There
some
is.
can generate. GPT can generate images too.
I think there was a wave of LMs that also generate images, but I think
GPT
now when you
is.
ask GPT, I think that now it's a different model. Maybe it's not again a different model.
No, I don't. I think it can edit images if you tell it to, so it might not be a different model.
Hmm. Yeah.
I'm not sure. Oh, good. APJ space with. Anyway, so it seems like. Yeah, user prompts. We're talking about how training the model on the assistant training makes it work different in the assistant tokens and the user prompter tokens. Or maybe this answers this goes back to consciousness consequences. Is the user simulation inside the model also conscious?
Or what do you say?
More consciousness stuff, don't worry.
Okay.
We can talk about that another day, anyway. And
GPT
this
is
one is
giving
about
more
shaping
open
the.
questions. Oh no. I thought I had a lot of answers, but apparently I still don't know a lot of things.
About what?
Damn it. About why it works.
Magic. Did you read the Niels reaction? I think he has interesting
No.
things. Go read
I
that.
first wanted to read the paper.
There's a lot of
If you
papers
want, we
to
can
read.
skim that one as well.
Go skim that one.
Yeah.
I read it the other day, but I don't know. I remember it. Maybe you'll have some interesting thing. You can remind me what Neil says on that one.
Yeah, I shared it, but I didn't read it. I wish there was more in the paper about why it works. Or attempts at theorizing why it works. It's mostly like, here's the math, here's all empirical data. And it feels like it's missing why the math works in the first place.
The stuff we were talking about, that previous stuff you were paying attention was already, you could see evidence of a structure of like, workspace, internal workspace stuff, some logic lens stuff.
Okay, I see.
Metrics.
Integrated information decomposition. That sounds like IIT. Representation reuse.
So they try to shape the J space with contextual reference training. Interesting.
Yeah. Training favors a shared internal currency. Concept presentation, many later circuits already know how to read. Stream acts like a shared blackboard. That's a cool analogy, shared blackboard. Well,
They're doing this for the actual models. This explains some things. Did you read the? By the way, did you read the reflection training?
no, just a sentence that it exists. But it's interesting. Also, that it helps with alignment, apparently.
Yeah,
And
but
think
I
that's the
wonder.
example
I
you're looking at.
noticed that Claude sometimes says something about how we need to search things very explicitly. I wonder if it's because they are training it with something like this.
I think searching explicitly is just reinforcement learning from verifiable rewards force. Fact checking everything.
Maybe.
I don't think it's related to this
When
much.
it talks about I should search this because and it I don't know, maybe it's extra likely to, if they are like doing this kind of thing, it's extra likely to reason about certain things on this way explicitly.
The rubrics for agentic RL is getting so complex. It's pretty fascinating. I found a paper where you have like rubrics, like complex rewards that evolve as the LM trains as well. So LM generates rewards for itself basically, as it's being trained with RL. What could go wrong, I wonder?
That's not the right, yes.
Alternate from the right to the SG stream.
Limitations. I'll read the limitations. And then I might just leave because I'm tired.
Couldn't you say that the residual stream is the broadcast, because that's where you put stuff and read from. I think that's an interpretation that makes maybe more sense. Just say the residual stream is the workspace.
Oh no, but I think thinking up as a subset of activations, but yeah.
Yeah, you can just see subset of. Well, actually, they are just interpreting residual stream, so they already do that set basically.
Inconsistent interpretability. Someone could try to figure this out. That the things on the other layers that are not the Workspace layers don't seem to make sense. So maybe
In the later layers, you mean?
no, on the earlier layers and on the later layers. Well, I mean, on the earlier layers, on the later layers is just going to be the output, the tokens, you know.
Yeah. I guess it's low level stuff like grammar, maybe. I don't know.
Inconsistent interpretability. Manifolds. Composite cross-interrelation, attaching and roles. No, but they mention stuff that maybe say manifolds. About how different vectors are related to each other.
I see.
The Workspace from not representation, that's important, yeah. You expect the improved revision what could the modern Workspace disambiguate Workspace expression from modern ones. Yeah, I think they need to separate the definition of Workspace from the global Workspace theory, maybe by using a different word, and from the JSpace stuff.
What's your point again?
That we suspect that an improved definition of what constitutes a modern workspace could be very effectively disambiguate workspace representation from modern ones. Huh.
Yeah.
And yeah, I think someone needs to try to study the workspace stuff separately. Without separated for the aliens, I mean. Relationship, model size, architecture, and training dynamics, yeah, this work for other people.
Yeah.
We like this on the server. Mechanistic account of how JSpace is populated.
Populated, yes. Yeah, we have not caused what caused the representation to enter it. That's also part of it. It's populated.
They are talking about basically training on the JSpace, but in a way that's technical, not training on the JSpace that I think says that they're going to still accidentally train against their interpretability tools.
Yeah, good fairy already does that a lot.
Tension schema theory. Or they have other theories of consciousness.
Oh, yeah.
That seems a bit bullshit.
Not enjoyer of the other theories.
I mean, I was thinking about that. Seems like there are some difference between some features that go on the engagement or not. Tension schema theory. Yeah, I guess maybe we can talk about the consciousness stuff on Wednesday. I
What?
didn't make the event again, or did I? Oh no, yeah,
It's
it's
Savings Day. Yeah, okay.
I'll be there and maybe talk about the consciousness stuff if you want.
Yeah. I might be working, so I'll see how much I'll multitask.
The paper is already too much. I don't know if I want to be at the appendix. Although I'm curious about the. Curious about the
It's
other.
interesting how all the different concepts can exist in this gigantic high-dimensional space and just compose and interact and work somehow, kinda.
I mean,
partially.
remember that's necessarily true because you can because that the attic space is Turing complete.
I mean, an NAND gate is also Turing complete.
Well, yes.
Or
If you have a bunch
composed
of
gate.
NAND gates with some memory, you necessarily in that memory you'll find you'll have all kinds of representations.
But you have to reduce all the combinatorial space. Yeah.
Well, not if you have memory.
Well, assuming finite memory. Or, yeah.
Template lens. That's this template lens. Okay. Template lens produces a vector corresponding to any given word of phrasing and preferring to memory. Cool. Oracle lens. Training a reconstructor model using template lenses to map arbitrary phrases to corresponding template vectors. I feel this is another paper. This combination of these two things is another paper that's somehow on the appendix for some reason with only two examples. I'm going to figure it out right now.
Hmm.
I wonder if all of the figures on these papers were made by Claude.
I've seen someone run it through Pengram, and the whole paper seems to be partially Fable generated or something, which I'm not surprised.
Trying to try. Here's the dumb thing. The model has a bad thought when it wants to say something else. When you force it to say something it doesn't want to say.
It has what?
It activates the bad vector when you are make it say something that is not true or doesn't want to say. And it curses internally when it gets the thing wrong.
Yeah, I've seen that.
This would be cool to spend some time looking at the J-Lens stuff in Europedia, but anyway, I think maybe one of you guys has something to say, but otherwise I'm too tired. I kind of been a little skim most of it, and I think I'm just going to close the recording and collapse in my bed.
Yeah, also getting sleepy and a bit of headache.
I should probably have dinner
Yes.
first, but yeah.
Oh
I
yeah.
was going to do something at the reading group that I didn't do it, but never mind. Oh, I got
What do you wanna
disconnected
do
for a
with
minute.
reading or changing something?
Anyway, yeah, people are not having takes, I guess. Sagi, does you have some take? Do we end it here?
Yeah, no takes. Go ahead.
Okay. Yeah, if we've been here for hours, let's just finish it.
More math Mulkatiri, please.